going live. You're live. Very epic.
Pop the link.
I did.
Oh. Where?
Everywhere but hash voice, I suppose. I'll put it in hash voice. There we go.
I'm reporting you for spamming.
That's reasonable.
Right click. If I ban you in voice, does it? You just like leave voice? You do, right?
Yeah, I just get kind of snap.
Oh yes, we actually are streaming in 1080p. Thank God.
Oh, and you can actually see my code, not Discord share where it's like.
Yeah.
360p.
Incredible.
Wait, Zach, it says you're on Nitro.
Hmm?
It says you're on Nitro. What? Do you have Nitro?
No.
Oh, it's saying that if I click this button to subscribe, then I'll be able to stream your thing at 60 FPS, Zach.
Wow.
Whoa.
Yes,
That's
I need
crazy.
my frames, bro. Like, I want to see that curtain movie, you know? I need to see all 60 frames of that code selection.
Wait, make me a mod, Zach. What the hell?
Okay, type and I'll make you a mod.
So,
I did.
Shrey, what
Did you
Shrey
type?
happening?
DP1911.
DP, hold on, remember what the fuck is
C74362 as well, I think.
Shrey is now moderator.
Introduction to C code. Wait, what,
It's
how
essentially-
many introduction to programming courses are there? Isn't there like
It's-
computing 1A
this-
as well?
No, Computer 1A doesn't exist. The DP191 is like USW. It's not run by USW, it's USW Global. So it's like-
I'm sure if I'm wrong. Computing 1A doesn't exist. Search computing 1A, it's literally called 1911. It does exist.
I know that was it was a joke. Such.
Yeah, sure.
Whoosh. The joke is that in CSC we've never heard of Computer 1A because we do 101. That's the joke.
Yeah, that's called covering
Right,
your arse. I think that's really a joke.
What? That's the second time you got whoosh today, Willie. You're gonna cope with the third?
Listen, the first time I understood, right? Like, fair play to you.
You didn't understand. If you get whooshed, you don't understand getting whooshed. That's the definition of getting
So much
whooshed.
like later on, like give it a viable whoosh. You just messed up and you're not just covering it with a free whoosh. I'm not son of whoosh. You're gonna stop with global diplomas only. What the hell is a global diploma?
Google it.
Yeah.
Basically, it's just a bridging. As far as I understand it, it's a bridging degree.
I hope you understand it, considering you're the course admin.
I mean, I need to understand the degree to understand the course, right?
Some extent. So is it like 1511 but like at a slightly more basic level?
No,
No,
same difficulty.
It's actually there's more content because it's running 12 weeks
Yeah.
as opposed to 9.
Yeah.
Interesting.
It's just different audience and less people, usually.
Cool.
Alright.
So basically budget Tom this time. That's nice.
Right.
Shrey, do you want to... This is a very tough first exercise.
Okay, so we're doing what's called Rustlings, which is like it's a library of exercises on a bunch of Rust stuff. So there's like we start with variables and if statements and functions. Eventually we'll get to like more complicated stuff. What I got currently is code editor, VS Code, obviously the best editor for this use case. Oops. And we've also got a terminal. This terminal is running with Rustlings custom software, which will it'll continue to compile the current one that I'm working on, and it'll tell you when I'm done. So this exercise is asking me to make this work in Rust. We use let, to me use variables. I don't know.
Yeah, so a lot of the exercises are in the format of, it's usually this doesn't compile, make it compile, or it'll be like this compiles but prints the wrong thing or something, or this assertion fails or whatever, and make the code work. And if you want to do exercises yourself, you can go to literally just Google Rustlings and you'll find it on GitHub here, and you just do a curl, or you can git clone it and do the exercise yourselves. I think there's like... Do we know how many exercises there are? I think there's like
A lot.
30 or 40 is my guess. I'm not sure. Some of them are quite simple, some of them can get quite tricky. You know, I haven't actually gone through the whole thing, but it looks like pretty good content, I think. Yeah.
Yeah. So, what are we doing? Oh, yes.
Oh yeah, so now it says
say-
the code is compiling on the left.
Yeah. This code is compiling, yay. You continue to work the exercise or jump on the next one by removing the I'm not done comment. Let's remove it. And now, when I save, it'll be like, oh, my light just changed color randomly. It'll be like, we're doing variables 2 now. So let's open variables 2. Make me compile. Let x equals 10, print 10. What? Do I just give it a value?
Yeah.
Okay. Cool.
Yeah. Honestly, it's actually, it says it's not compiling. Like if we look at the error message before you put the equals 3 there, it says it's not compiling because x doesn't have a type. Which is like, yeah, okay, so it says consider giving x type. Do you know how to give x a type without like initializing it? Yeah. And then what will it say now? Use of possibly uninitialized variable x. Cool.
Which is bad.
Yeah, and this isn't like C or like DCC or Clang or GCC or whatever, where it does like some certain analysis and it'll try and catch where things are uninitialized, but not all the time. In safe Rust, it's literally impossible to use an uninitialized variable, which is very epic.
Cool. Cannot assign twice to immutable variable x. So
Let x is 3, number, x is 5, number.
so there's
So can you use like unsafe Rust? You mentioned specifically like safe Rust.
Mm-hmm.
Can you...
So sometimes you do actually want to use, like, you do want to meddle with things that are... There's nothing wrong with having uninitialized memory, which sort of Rust has this... It's hard to write the right rules where you can have uninitialized memory, but it prevents you from using it in any sort of way. So sometimes the compiler, and this is sort of general across all of Rust, in that sometimes the compiler is just slightly too strict, because if it wasn't as strict as it was, it would be incredibly difficult for it to actually analyze everything, and the compiler would take ages and would be way more complex than it is. So it has to sort of make some trade-offs in certain places, and that's why you have unsafe as an escape hatch. So unsafe is not, like, there's sort of a bit of a misconception about unsafe in Rust. And just to, like, demonstrate here, if I just go, I have my Rust file, let's go, function main, this. To write unsafe Rust, you literally use the unsafe keyword and then make a block, and then your code will go inside this block here. And this is sort of like to let you get around the certain safety rules of the language. You don't just get like free reign over everything, but it sort of disables a lot of the checks. Unsafe in Rust is not for you to do things that are unsafe. It's actually kind of like a bit of a bad name in that sense. It's not for you to do unsafe things. It's more of a, I know what I am doing is safe, but it's too sort of like intrinsic in my application for the compiler to actually realize, right? Like this is like, it may be, you know, I store uninitialized memory and like it theoretically could be accessed, but it's not being accessed because I've held certain invariants over here and there. Therefore, it's just literally not possible. So it's more not...
Specifically...
Yeah?
Sorry. Well, specifically, there are a number of guarantees the compiler needs to be able to checks. Usually, in safe code, it can make all of these guarantees itself. In unsafe code, that's where you enforce the guarantee. Because it can statically be a holding.
Yeah, exactly. Cool. So, yeah, you can get around things like mutability. You usually sort of backtrack through a reference and turn it into something called a raw pointer and back out. But you don't just sort of do it for just random kicks and giggles. Like, you should be very sure that this will be safe, and usually it's very good practice. Everyone in the community will write what's known as a little safety comment above every unsafe block that explains this is safe because, and like you sort of say this needs to be like that and that needs to be like that, and therefore this will be, you know, this won't actually be unsafe. And you try and make your unsafe blocks.
Do you have like unsafe
as
block of codes and safe block of codes in the same like function?
Yes. So that's sort of the main principle of safety in Rust as well, in the sense that you want to provide safety, like you want to provide a safe abstraction and use sort of unsafe code. So if I actually have a look, a really good example here would be, let's pull up the docs and look at something like vec, right? So vec is just like, if you know, say Java, it's like an array list. Python, it's like a list. It's like a growable and shrinkable heap allocated list. And if we have a look here and type the word unsafe, we will see there is actually like quite a bit of unsafe littered throughout this code.
There
And
shouldn't be much.
there's a good 71. A lot of these are going to be comments and stuff, but they're sort of doing things. Say this safe function truncate is completely unsafe, everything it does, but it knows that this is going to be safe to do because we hold certain invariants. We know more than the compiler knows here. And you do it a lot for like optimization or to sort of provide a certain interface, like a mutex or whatever. And so, yeah, you can provide, as long as your function will be safe for any input and any state that the program's in that it's given, then it's completely fine to sort of use unsafe in this way. If you want to use an unsafe block inside your code and you actually can't verify that it's going to be safe to do, like the person who's calling your function needs to ensure certain things to make sure your code doesn't do anything bad, that's when you declare your function itself as unsafe as well, like this. So from raw parts in is a pub unsafe function. And so for anyone to actually call this one, they will have to sort of read through your thing, figure out when it's safe to use, and then call from raw parts in their own unsafe block. And then in their unsafe block, they would have safety. I'm allowed to call this unsafe function because I've made sure that this, and this will hold, essentially.
Thank you.
Very big tangent, but very cool.
Rust safe. TLDR. Right, so this doesn't work. Cannot assign type twice to a mutable variable. So we want to make the variable mutable. So we'll say let x be a mutable variable, which holds the value 3. Yay, it compiles.
Oh, it even gives you the output as well. Number 3, number 5. Cool.
Yeah. Time for number 4. Maybe compile. Let x, so x is an integer of 30 bytes. JK, not bytes. So let's make it be some number.
Cool.
Yay.
Yeah, just because it was uninitialized. We already sort of went through that one before.
Yeah. Oh, sorry. Oh, but I think it's a string found integer. What? Why is this?
Ah. Yeah, so
I don't know if that's how they want me to solve it, but it works.
that does compile. I would say go back, like Control Z back. Make this compile without changing, only changing line 9, I would suggest.
Yeah. Do something that a lot of C programmers will tell you is a bad idea.
I think we missed that.
I just instantly self-muted them.
Oh.
I heard is a minor. And I was like, I don't need the rest of the sentence. What?
Ah.
Do it.
Do you wait? Let's see what. Try the Rustlings hint. Let's see what it says. If you need your hint, because it says in the line 2.
Rustlings hint. There variables 5. Oh boy.
Oh my god.
That is.
Yeah. Okay. So this is what they're looking for.
We learn how to make a mutable variable mutable. We first this enhanced models as exercise because we want to find a different type. Sure. Well, first of all, let's make. I don't know. that means mutable. We're going to change it. Sometimes you may also have reasons and real names. You can throw the types. First shadowing. You can just do. Right. You can just do this, right?
Yes. So the idea here, lots of languages actually have this support nowadays, but it's basically a new binding number overrides the old binding. So the two variables literally have nothing to do with each other, apart from sort of sharing the same name.
Many languages have had this for ages.
Yeah, for sure.
But a lot of languages will advise against it, but it's a fairly common thing to see in Rust.
Yeah, that's true.
But just a quick question, like the first binding, wherever that was stored in memory, when you do the second binding, does it erase a bunch of
Yes.
memory?
It
That's
will.
not inaccessible.
If there's you could still hold a reference to it. If Shrey did something like on between line 8 and line 9, he could say let number ref equals ref number, in which case it would be sort of held longer and you just wouldn't have any way to reference, to talk about the original owned value. But since he's overriding it there and there's no sort of other references there, if he gets rid of line 9 again, then that will instantly be dropped at that point.
Right, so is it deleted from memory then?
Yeah.
Whatever was there, it's overwritten?
Yep.
Okay.
So the Rust terminology for this, in this case, is the word drop, because you could just say it gets rid of it in memory, which is true. It will sort of free up the resources that it uses in memory. But you can also have destructors in Rust, which is sort of like, let's say I have a type, some struct foo, and I want to execute some code whenever foo goes out of scope. So a good example might be if you have a file, or a handle to a file rather, and when that file handle goes out of scope, you want to close the file. You want to clean up your resources. And so we use the terminology drop because drop is referring to running the destructor, the drop function on that type, and then freeing up the memory that it was using.
Yeah, makes sense. So do whatever you need to do to kind of eliminate or exterminate that type. So
Yeah.
And it varies from type to type, like you said. Cool.
Yeah. Also, I see Jay asked in the YouTube chat, can't watch the previous streams. This is the first one that's gone up on YouTube, so unfortunately not. The old Rust streams are lost to the depths of time.
To be
Yeah.
fair, you're not missing much. It was a lot less structured. This is like a workshop pretty much. This is far
Sure.
more structured.
Cool.
This isn't very structured. This is just me going to someone else's structure. Cool. Also, this is a good example. Later when we have the ref, if you use the ref afterwards, it's still pointing at the thing. So it's
Yeah.
in this case, it's Rust knows that, right? So it's not dropped because it's
Mm-hmm.
there's still something pointing to it.
Yep.
Cool. Variable 6. Let's go. Const number equals to 3.
Oh,
Right.
the error message is helpful.
Okay. Now what?
And that's it. So the lesson here is that constant variables, you need to explicitly declare the type.
Cool.
I mean, they're not variables if they're constant.
Sure, okay. You can have const mute though, or is it static mute? Maybe you can't have no, you can't have const mute. You can have static mute.
You can have static mute.
Yeah,
yes.
yeah.
Time for functions.
Oh, cool.
Gross. Make me compile. Okay.
Just delete all the code.
Wait, make me compile here. Let's do this.
Yeah, yeah.
I think it's less that constants need to have types and more that global items need to have explicit types. So it's not really.
Yeah,
to do with the
that's
fact that
fair.
it's constant.
Like functions need types and stuff.
Can you have global variables? And do they need to have types?
Yeah, so
Would they
that's
need to have
what
types?
that's what you would call
That's what I guess.
static.
Do I need to have? Can I just do this? Would that work?
Yeah, that works.
Oh right, cool. Okay.
Mhm.
Well,
So there's sort of like we know that functions implicitly return that unit type, just the two parentheses like that, and so that won't change anything. That also won't change anything, and also you can do function call me parentheses arrow to unit, and that also won't change anything. These all mean the exact same thing.
Yeah, I had this before. Yeah.
Yeah. So, and like unit is a type that there's only really, it's an empty tuple. So there's only one way to construct it. So it ends up being a really sort of handy, let's say like placeholder type that's used in a lot of places.
Unit is actually a very important type.
Yes.
Yes.
It's the equivalent. It's equivalent to 1 in arithmetic.
Yeah. And then, yeah.
Which you'll learn about more in 3-on-4. Yes.
You'll learn more about it in 3. It is equivalent to the number 1.
It is very epic.
There is another type called void, which Rust pronounces exclamation mark.
Never, yeah. So that one's called the never type. It's not stable yet, unfortunately. Like if I go, well, I guess I can just do bang like this. But it's still nightly only experimental because they're stabilizing a couple of things about it. But yeah, it's the type that...
You can make something that's equivalent to it by just having it.
Yeah.
Yeah.
Cool.
Cool. Functions 2. Oh, I gotta remove that. Oh, I did do that. Call me number. Okay.
Right, so function parameters need types. Yeah, cool, that's it. Function parameters need types.
Do they need? What if I just did this? Would that be fine?
No.
Oh, they all need types. Right?
Yes, always need to provide your types.
Ah. Oops. Cool. Function 3. Make compile. Call me input 2. Ring x1. Oh, what is it just like? Supply no. Okay, sure. Damn, that was difficult. Okay, number 4. Expected type here. Okay. Well, it's returning an integer, so I'm just going to say I32.
Yeah.
Yay. Cool. Yes, Rust has the last expression. Words are hard.
Mhm.
The last expression is always returned. So this one's the last expression. This is this is
So-
equivalent to saying return. Right?
Almost. Not quite, actually. The return doesn't go there.
Huh?
The last expression in the function is actually the if expression.
So, anything
Oh.
that has a block
Yes.
evaluates to the last expression in that block.
Yeah. So in terms of the function,
if-
yeah.
The return block.
So the if block, each arm will evaluate to the last expression in that block. So that's what the if, as in
Yeah.
the total thing, evaluates to, and then
So
the
it'd go
function
like
evaluates
this.
to whatever the if. Yeah.
Yeah.
Mhm.
You want to stick a semicolon after the if, but yes.
So wait, return price minus 10 won't work. It'll just...
No, it will work. You can do it like that, but
Really?
it's rustisms. What do you call it? Pythonic. Rustonic. Yeah.
I didn't think that was valid syntax
Which one? That, yeah.
without the semicolon at the end. I guess it is.
Oh. I think because return evaluates to the thing it's returning as well.
Right.
Yeah.
Just
Right.
a really weird
Just a quick question, like,
effect.
if you did, like, instead of return if you did return price minus 10, return price minus 3, is that any different than how it functions?
Nope. Same thing.
No. Do I need? No, I don't, because it's gonna. This is expression of return.
Yeah. You should be including semicolons if you're doing return like that. It's sort of like this weird side effect that...
Same with JavaScript, kiddos. Always use semicolons in your JavaScript.
Yes. Cool.
Square, make me compile. This reminds me of when I first did Haskell for 3-on-4, the first example was like the double example, where it was like you double and then you double. That's what I'm thinking of. This square. Right. What is the issue? Because I thought you found unit type. Oh, because it's got a semicolon.
Right. Why is the semicolon problem, Shrey?
Because otherwise it's not the last expression. I don't know. It's a statement. If it's a
Yes,
semicolon.
it's a statement. If it,
It's not the last statement, so you'd say the last
Sorry,
statement
yes.
block
Yes,
is
yes,
the one
yes.
that's evaluated.
Yep. So, like an expression is no semicolon. Semicolon at the end makes it a statement, and that whole last expression thing only works if the thing
Sorry.
is an expression.
The whole thing is a statement either way. if you put a semicolon at the end, you now have two statements instead of one.
Sure. Okay.
Oh. What's the other statement?
The implicit unit return.
Yeah, it's just the empty string which has the type unit.
Yeah, like that.
Okay.
Yeah.
The more you know.
And that's actually, if you look at the compiler error again when you do the semicolon tray, notice it says expected I32 found unit.
Oh.
'Cause
In this case, the last statement is like the unit.
Yes. Cool. Moving on to what does it want me to do next? Functions. Oh wait, what? Didn't I do? Bigger. Oh, if lol. Okay, thanks. Alright, if one. Complete the function, return the bigger. Do not use the function call or additional variables. I can't. Right, so I want to return A if A is greater than B, else B. Which I can do in one line or one thing, I think. Like,
Yeah, one thing.
if A and B. Oh, B on it. Else A? No. Like this.
You don't
Oh
need
my gosh.
parentheses around your condition.
Yes.
Oh, really?
Mm-hmm.
I'm just going to yell at you for everything that
No, don't worry about it.
format would tell you to do.
Oh, I don't like that. That's gross.
I mean, you can put the parentheses there.
I will. Out of spite.
It's not Rustonic.
Rustonic is bad then. Cool. So this works because it's like the same as this. We had in the previous examples where return the A, return the B.
Mm-hmm.
Right? Same thing.
Yep, because the if is the last expression in the block, in the function block.
Yeah. Cool.
This is what we call a ternary expression.
Mm-hmm.
Because it has three parts.
Fizz if foo. If fizzish equals to fizz foo else. Really? Is it not else if? Oh, what? What's the... Oh wait, lol. It's in there. Wait, is this not the syntax? Is it not else if?
Yeah, no, you're right.
Right, what
So
comes after the word if?
Why isn't it autocompleting this variable for me? What the heck? Okay.
Unclear.
What does it want? It wants fuzz goes to bar.
And then otherwise, what does it want? Literally anything else?
Baz.
Just remind me of this was.
Yeah.
Is
It's
it
fizz
fizz
if
buzz?
Oh,
fizzish.
Fizzish, yeah. Well, it's fizz fuzz baz,
Fizzish.
not fizz fuzz bar.
Fuzz
Why
bar.
didn't it auto? That's weird. I don't know if that was.
Yeah,
I thought I
that
was
is
confused.
that
I
is
was
a bit
like,
odd.
Is it
Oh,
wrong? Like,
probably because it was it was struggling to parse the file potentially. The RL, like the language server, was having a tricky time because you have else if with nothing there as a guess.
Yeah. Cool. Now I want to go to quiz one.
Oh, quiz!
Wait, guys, I can't plagiarize. I'm on call. Wait, I'll be right back. Oh, I have to write functions. Oh, can I just not? Alright, fine. This is a quiz for following sections variables. Mary is buying apples. One apple usually costs 2 rust bucks, but if you buy more than 40 at once, what is that? They cost 1. Write a function that calculates the price of a... Yep, given the order amount, right.
The marks for this quiz will go towards your final course mark.
Num.
The course being social validation in front of first years.
So-
If...
Okay, I'll save my pointers to the
Yeah.
end. Yeah.
Yeah.
Pointers or references?
Yeah.
More than 40 equals 1. Oh, right. Okay. Return type true. Okay. That was
Yay!
it? Wait, that was it? It gave me all these errors.
It's because it's coming from a macro.
Right, no implementation type equals of integer equals type.
Yeah, so it's coming and it's saying partial leak of unit is not implemented, and you know
Right, okay.
it's having a sad time about that. So there's two things here. First of all, obviously Rust format is going to scream at you for line 26. Because you don't need them. Like, yeah, you don't need them.
Fine.
Looks
The-
better if you've been staring at a lot of C.
Yeah.
True. You're right.
The other thing is, you said num I32 to I32, right?
Mm-hmm.
Is there anything better?
Oh, probably should be U32, hey.
Yeah. So Rust makes it
nice.
really easy to use unsigned types. So like, you know, if unsigned types are the only
Why would U32 be better?
because it's a scalar amount of apples. Like it's a discrete amount of apples.
Right, but that if it's a discrete amount of apples, that only tells me to not be floating.
Sure, but like you're probably not going to want to buy negative apples, and you're like,
Right, but a negative price might make sense.
okay, so you could do I30. You could return I32 then if you want.
Oh yeah, I guess so.
So if it, and you may end up deciding you want to return.
Negative price makes sense. How would a negative price
Refund?
Say the economy's gone bad.
Oh god.
Pay you to take the
I-
apples.
I think
Okay,
I
I'm
think
sorry, my quiz1.rs does not take into account the state of the economy.
Wait, so wouldn't then you need like the like num to also be I32? Can you like pass in an unsigned and
No, because this can be, you can say, you can do that, right? Alright.
so. The problem is you're trying to you're returning num, or you're trying to multiply num by an I32, and the types aren't compatible.
What?
So
Yeah,
So,
why is it-
unlike many other languages, Rust will never implicitly cast between. Cast between.
What?
it's pretty easy to.
Trivially, you have to do it explicitly.
You can just do num as no. You don't do that. That's disgusting. Num as I32. Yeah.
I hate that. That's gross. Is there a shorthand for that?
No, the whole idea is that it's not something that happens automatically. The reason it doesn't happen automatically is because there are hundreds of thousands of millions of things that causes bugs. It is one
Is
of
there-
the hardest things
Okay,
to get
that
right in
that makes
C.
sense. But is there a shorthand for it? I just don't. It's so long. Like, can't I just do this?
No.
No. In this case, you'd probably just make the number of apples in I32. You're really not getting any benefit from having that being unsigned.
So that got me started.
Potentially.
Alternatively, you could shadow num and create a copy of it that is I32.
That's usually what I end up going
That's the
with.
first line of the function.
If I end up having to cast multiple times, you just do the casting once and then.
Oh, so you
that's
can just
why
go like.
shadowing of variables is actually pretty common.
You don't need to specify the type. But that hasn't really done much. If you want to do U32.
It's like this, right?
So that won't work. It won't implicitly cast your types.
But didn't you say you could just shadow it and create your own?
But it won't implicitly
Yes,
cast
but
your
like
types.
The num on the right side of the equal.
Oh, I see. Okay.
Num on the left side is an I32.
And now, since you've said it explicitly there, no,
Then,
no,
like, do something like this.
yeah, you just do num. And since you've actually, it knows that the right hand side will be an I32, so you don't need to state it again on the left hand side.
That's cool, I guess. I can see where that
Is
is.
it just like typecasting? Or just
Yeah.
typecasting?
Yes.
So, yeah, Shrey, it would actually be suggested as well that you just get rid of the I32. Yeah.
It's not good.
Mhm.
Yeah, it's cool. Put your function here. No. I'll put it down here.
You failed the quiz.
Oh,
Oh, move semantics. Nice.
I'm sorry, you've lost 1 mark from your course marks.
You're not getting 4 marks in social validation anymore. On a project.
Incredible.
Moving
Yeah.
on. Cool. Vec new, fill vec with vec. Oh, what the heck? Okay, new vector vec 0, fill vec 1 with vec 0, print out vec 1, print out, push 88 into vec 1, print out vec 1. Right, so what's going to fix this fill vec thing that's not working? I think I did this one like a week ago, but I can't remember how.
Good.
What's the error say?
That's a good question. Consider change error immutable, but cannot borrow the immutable, right? So you can't. This is an immutable variable, so therefore I'm trying to. The push function needs to be immutable, right? So
And
therefore I can.
I'm gonna pause you for a second just to like.
Yeah.
So we're gonna have a look here. What was the name of the function again? It was
Push.
Oh, push. Right. Good. Vec push. Oh, that's whatever. So you can see this takes a ref mute self, and therefore we need. Let me just make it a bit bigger. Oh my god, I lost it. Element of p for push. So it takes a mutable reference to self. Therefore, when we do like vec dot push with our value, we need to have mutable access. So dot's a very special operator in that it'll sort of try and take references and dereference things, and then take two reference to it, and then dereference it twice, and keep sort of doing this pattern until it tries. It'll keep trying and to get to what you want it to be.
Right.
So it'll automatically go take a reference, dereference it, but when it takes the reference, it'll go right ref mute self or ref self or whatever, and it'll just go, oh, I'm almost there. I can't access it because I'm not mutable. So by adding, where'd you add Shrey?
There.
Yeah, so now when it does vec1 push, it can actually get a mutable reference to vec1.
Wait, but how is this move semantic? Isn't this just like?
That's not... Well, there is like a move on line 9, but it's not really demonstrating much in terms of move semantics, which is, yeah.
Alright.
Vec 0 gets moved into the fill.
Yeah, but that doesn't really get demonstrated
and then
here
it
yet.
gets moved back out
Yeah.
as the return.
Oh boy.
Okay.
Alright. Borrow of moved value vec 0. Right. Move the code says vec 0 type vec I32, which is not implement the copy trait. Right, so it's a move, yeah. And then it's trying to use. Wait, but shouldn't this move back out?
Yes, correct.
So then why is it
So where?
complaining?
Look at where it's... Yeah, correct. Look at where it's moved back out to.
What do you mean back
So
out?
you call fill vec,
Yeah.
right? You move vec 0 into fill vec,
Yeah.
and then what does it do with that return value of fill vec?
Oh, but the vec move. to
So
vec 1.
vec 0 has been moved into vec 1.
Right. Can I
So,
just
so
vec 1?
when you pass vec
Right.
0 as an argument to fill vec,
Hmm.
the value is removed from the vec 0 variable passed into
Right.
fill vec, and vec
Right.
0 now doesn't refer to it. It has
It
no
just
value.
doesn't exist. Yeah.
Correct.
Right.
Why?
The vec 0 binding is useless.
But why?
Because the value has been moved out of it. There
It's
is
simply-
no value in the variable vec 0.
Let's...
As if I've taken this, copied it, and I've taken this and moved it into here.
So because this is a very sort of weird rusty thing, let's take a little aside to go to where they actually talk a little bit about moving. So let me go... where is it? Did I go too far? Blah, blah, blah. Surely I've gone too far at this point. Where was it? Ownership, there we go. Will we see moving? Let's see. Ownership rules. Blah, 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 blah. Where does that interact with moving? Okay, whatever. I'll just open up a terminal and we'll explain. Okay, so this is sort of one of the like core principles in Rust, which is, I think probably the easiest way to explain this is to distinguish between the idea of copy types and then non-copy types. So as an example, just sort of take my word on it now. A few examples of copy types might be something like an I32. like a 4-byte number. We might have something like a boolean, which would be 1 byte usually. We might have, what's another interesting copy type? A shared reference. So let's say if I go x, let's say x ref is a reference to x, is a ref i32 equals ref x. These are all what we would call copy types, and then let me give a few non-copy types. So for example, a vec, let v is a vec of something, doesn't actually matter what it is. It could be a copy type like i32, and I'll say that is going to be a vec of 1, 2, 3. What's another good non-copy type? You could have things like hash maps. Option, I suppose, is fair. Option we know is going to be either sum of this t that we have here. Let's say this will be a boolean, doesn't really matter. It'll either be sum of that boolean or it'll just be nothing at all, like a none. So I'll just do sum of like false. And let's say we have some custom user-defined type. So I'll make struct my struct, like that. Cool, and then I'll just have let s my struct equals a new instance of my struct. Okay, so as I said before, these are copy types and these are non-copy types. So what we have here, there's really nothing that's like going on between the two here. They're both acting identically. It's only once we start getting into these like move semantics where things start to happen differently. So let's say I go println bang of x is going to be something, and I give it x. And then I say something like this. Let y equals x. And then I say println bang of x again. And notice here I'm saying x and not y. Right? So I say this println, I let y equals x, so I create a new value, a new variable y, which is assigned to x, and then I go and print x again. Right, let me open up two windows here so we can sort of see what's going on at the same time. Cool. And yes, I know, it's fine. And then I will go rustc foo. Yeah, don't worry about it. And we see it goes x4, x4. So it prints out x, it prints out x. Like, that's working as we expect. That is because x is what we would call a copy type. So what it does here is, since i32 is like a really rather like small thing, it's 4 bytes, it's not really that big a deal. You know, it's very cheap to create, you know, infinite copies of this thing. Whenever we say let y or something equals x, we copy the value of x into new memory and allocate that to y, and everything's all happy and nice. But you can imagine if we had some like huge structure that we may not want to like clone that whole thing across, make a whole new one, and then like potentially do that many times. Like, you get this huge memory cost. So copy is a little marker that says I am a small simple type. I don't carry a lot of value, therefore feel free to just like copy me around the place and act like most other languages probably would in this case. However, if we have a non-copy type, so let's say I try and print v now. So I'm going to print the vector. I'm going to print the vector again. So if I don't change anything here, if I just rustc it and run it, we see it prints the vector out twice. Now let me set y to be equal to v. Rustc it, and we get this big error message. Borrow of moved value v. Right? This is because v is non-copy, so when we do this let y equals v, the value of v is moved into the variable y. Right? So y is now the owner of this value, like this vector we have here, vec123. Y now owns this, and v doesn't. This binding v is pretty much useless from this point forward. You could still sort of use it, but like, yeah, the binding you can just consider dead from this point forward, and therefore this code doesn't compile. And in our case that we're looking at here, these move semantics, right? So moving this variable v into y, or the value of v into y, works the exact same with function parameters. So if I have a function foo that takes v, which is a vec of i32s, and let's say, I don't know what it returns. If I change this line here, let y equals v to be foo of v, exact same semantics. Because v is asking for a vec is not copy, then you get this unfortunate like move semantic here. So there is a couple ways to get around this. Like they've thought of this and be like, this is a bit nasty to deal with in certain ways. But it's really up to you how you deal with it. So I said before that a reference type is copy. So let's say foo just like printed out the first thing in the vector, something like that. Let's say it just goes print line v of 0, something like that. V doesn't actually need to take all the memory of the vector and own it, right? What would actually happen here when I call this is I would go foo of v, it moves v into this parameter here, and since it doesn't do anything with v, like, it doesn't return anything in regards to it, and it's responsible for it, it owns this value v, that vector actually gets dropped, like it gets freed when foo ends. So v literally doesn't even exist past this point in this case, right? But it doesn't need to do that. It doesn't need to be responsible for all the memory. It just wants to be able to read the first thing in it. So instead we could just say, let foo be a ref vec. This is actually not, you won't see Rust code that actually looks like this, but that's sort of a different story. If you learn about slices and stuff, you can sort of play with that there. But for our intents and purposes, this is fine, right? This actually won't compile because I need to say, give it ref v. But if I try and Rust C this now and run it, then we still get v123, and this function also works. It printed out that first thing in the vec. There is one other option we have here, which is, let's say it actually did want its own vector. It needed responsibility over the memory for some random semantic reason you have. Or the function signature just happens to look like this. Someone's made a bad function and I really need to call it. There's a way to copy a non-copy type, but you have to sort of explicitly say it because you're sort of assuming that the cost is going to be quite high. And that's the clone trait. So if you implement clone, and a lot of things do implement clone, not everything. So some things literally you can't copy, you can't clone, you just have your value, and it's a bit unfortunate that that's the way it is. But most things will end up implementing clone, and this will essentially do the same thing as a copy, but on a non-copy type. You just have to explicitly say, yes, I want to clone this, and it should like stick out. Like it should stick out like a little wart, because you probably, most of the time when you're like reaching to clone, you probably don't need to actually use it. It's probably like things have gotten a bit tricky, and it's like, okay, I'll just clone it here, it's fine. But there's a better way of writing it where you don't have that extra cost. So clones usually stick out quite a bit for good reason in that sense. And just to show you, if you wanted to say, what if I want to make, my struct only has x an i32 and y a u32. I know it's going to be really cheap. It's just going to be 8 bytes. I want my struct to have copy semantics. It's really easy. You just do this little, you may have seen derive before, which just says implement this for me. And you can give it copy. In this case, I'll have to say copy clone. And this will basically automatically implement the clone trait for you. So this function here, and it'll say whenever like it's moved around, just clone it. Just give it copy semantics. So it'll always clone that memory for you every time.
But do
that's how you do it.
you need clone in there? If it's like a copy type, you don't use clone on a copy type, do you?
So let's
Like you don't do x.clone.
Let's get rid of this for a second because I don't want to compile it for other reasons.
A question in chat in case you missed it.
Okay, 1 second. So the trait clone is not implemented for my struct. So because the way copy works, it's a bit dodgy of a story than that, but it's simple enough for now. Copy, you're required to implement clone on it so it knows how to actually copy that memory when it needs to. And that's sort of what the clone function is there for. It's a bit weird when you get to like side effects in clone, but getting a bit ahead of ourselves. So it needs to know how to clone it in order to be able to copy it. So maybe you'd even prefer for it to be written more like this. So I derive how to clone it, and then I derive how to copy it from there. And so then if I have in my main function, let x equals my struct of, x is 3, y is 2, something like that, then I can say let y equals x, and both x and y are still, they're both valid down here, where if it was non-copy, only y would be valid at this point. X would be moved out of, and you wouldn't be able to use it anymore. Would a string type be non-copy then? That's actually a really awesome question, because the answer is simultaneously yes and no. Rust actually has two different string types. There is one called ref stir. That's something like this. Let x ref stir equals hello. And a ref stir is basically, it's an immutable reference to a string, and that string, like, you can't resize the string through that reference. You can't, well, first of all, it's immutable, so you can't really mutate it, but behind like a stir in this case, you can't ever change it. Like if you imagine you had like a ref mute stir, it gets a bit weird, but think of it as a static size string. It will be like the 5 letters hello. You can't add characters to it. You can't like take characters away from it. And then there's another type. Let's call it x2, capital S string, and that might be written something like this. Oops, string from foo. Make this a little bigger. And this is what we would call a heap allocated string. So it's something that can be, grown and shrunk. It's essentially basically like a vec of characters, where it's, a list of characters that can grow and shrink and mutate and all this. And very interestingly, we can also turn capital S strings into ref stirs. Not the other way around, unless you, create a new string, like a new heap allocation, and put that value in it. But you can sort of turn a ref string, so like it's a really weird thing. You can say let x3, this won't compile, stir equals dereference x2. There's a deref trait in Rust, deref, and it says when you dereference me, what will I turn into? So for a pointer or like a reference, it'll turn into the thing it's pointing at, the thing it's referencing. For string, it just so happens that it'll dereference into a stir, so then you can end up referencing it again, and you get a ref stir. And in this case, this actually will compile, funnily enough, as you can see there. So you sometimes see these weird conversions in Rust where you see like, why are they referencing and then dereferencing, or I suppose the other way around, dereferencing and then immediately referencing, like that doesn't do anything, but you can sort of mangle types around like that, and it won't really do anything at runtime. Cool. And just to bring it home, ref stir is copy because reference types are copy. Capital S string is not copy because it's like a vec. If it were copy, you would end up with a problem where something like this. If I have let x be my string from foo, and then I said let x2 equals x1. The problem is, implicitly at the end of this block, we're going to have drop x1 and drop x2. Or if you're coming from C, just replace the word drop with free, because they both need to be cleaned up. They're both valid, at the end of the function, because we're imagining that they were copy. And what would happen is these would both have a malloc pointing at this same foo string, right? It's malloc some space for the string, and then x1's pointing at that string, x2 is also pointing at that string. Then you drop x1, which frees, that malloc away, and then we drop x2, and we get a double free. And we get that security bug, very dangerous, scary. So we get that double free there. Since this is actually a move, there's no drop x1 because it's been moved out of, so we just get the single free and everything is bueno. And that's basically that. Is there any more questions from that? Cool. I'll bounce back to Shrey.
Cool. Rust strange. Cool. Right. So this is saying that vec0 has moved into vec1 into fill vec, and therefore it's gone here. So I'm going to just clone, make a temporary variable that gets moved in. I don't know. Vec0 dot clone, and then the only issue would be. No, that's fine. This isn't the solution for everything though, right? It works, yes.
Cool. So that does work. There's a slightly more succinct way to write that without the extra temporary variable.
It should just be vec0 clone, right?
Yeah. So it'll move the cloned instance in instead of the original vec0. And that'll still work. Probably the right solution here would just be to take a mutable reference to the vector in fillvec.
What?
So modifying the function fillvec.
Oh, right.
So instead of like consuming the memory of a vector and then like giving it back, instead just taking a mutable borrow of that vector. Yeah.
I think the next one does that.
Ooh.
It does not.
Make me compile without adding new lines, just changing existing ones. Oh, well. No.
Oh.
Oh.
Damn. I thought I had it for a second. Let mutable x1 equals blah blah. So just changing mutable back. Can I borrow as mutable?
Where are the errors coming from in this case?
I don't know, I'm ignoring them, I should leave them hate. Coming from usage of the vector.
Yeah.
I cannot borrow mutable because it's trying to.
So
Should this be mutable?
So mutability, in terms of when you're dealing with a reference, then the mutability is the mutability of the reference. But when you're dealing with an actual like type, like an actual value, it's attached to wherever that binding is declared. So look in your function. Look in your function 21, 22, 23. They're all talking about vec, right?
Yeah.
Where is that exact binding vec coming from? Right there, right?
Mm.
Is that a mutable binding or an immutable binding?
Right, so like even if this is mutable, which it is, it's just defined to be immutable unless I change it to be
Well,
otherwise.
it's the same thing as if you have a let v equals vec, right? Like you own the value, but you haven't declared that binding as mutable or immutable.
Oh, right, I see. Cool.
And so now there. Yeah, sure.
Move something's 4, almost out. Let's go. Not a value. Well, that's awkward. How's it? It's just.
Oh, I see. Okay.
Oh, let's just create one.
So they're saying we don't want fillvec to take a vector anymore. It should just return 1.
Oh, it's doing this. I can't do this, right? Because it's not gonna. WTOA. What? Can't do this. Consider type.
I'm surprised. Oh, it's the wrong. You're looking at the wrong vec. I was gonna say I'm surprised it can't infer the type from that because it can. Look at which vec new it's pointing at. The error.
Oh.
No.
I'm sorry.
Look at the line that the error's on. Yeah. It doesn't know what that is a vec of. But I don't think it's even used.
What? Silence errors.
How do I sense these?
Oh wait, I just do this, right?
Yeah.
Here's the solution to this exercise.
Oh god.
So,
Perfect.
It doesn't even work. Okay. Let me do that.
So I don't think vec0 is actually used at all. Hence why it can't really infer the types.
Why isn't this? Okay.
Oh, you killed Rustlings.
Oh. Yay, I did it.
Wait, did you?
The code is compiling.
That says functions 1. Oh, wait.
What?
Wait, is it? Yeah, this is like functions 2, I think it's doing. For some reason. Like the Rust...
Oh, it's doing.
Oh.
So export, if I remove this compiler bug. Oops. Save.
Okay, cool. Oh, right. Yeah, it's pointing at the next one. Okay, cool. Nice.
Yay, absolute winner. Why doesn't this get dropped? Oh, good, returned.
It moves the value back out. So actually, yeah, that's a really good point. If you can move a value in through a function parameter, you can also move a value out of a function through the return.
Yeah. I am done. What does it want me to do now? Primitive types.
Ooh.
What's a primitive type? What?
The sort of built-ins per se.
It's not like is evening. Is there truthful values in Rust? Can I just do one?
No.
There's no truthful
Well, I
values in
mean,
Rust?
that won't. The if won't compile. The let will, but the if won't.
Why would be if?
Because if I32,
So it only takes its balls and do like.
it'll only take bulls.
Because it'll do implicit
It's
casting.
something that would implicit cast.
Yeah. Cool. That makes sense. That's cool. No, what am I doing? Yikes.
It is both morning and evening.
Yes.
I think it's asking you to do it in terms of is morning. Wait, what? Hang on.
Wait.
Let is evening equals probably some function of is morning. Yeah, that's what I was imagining.
I mean, there you go. Cool. With primitive types 2. Okay. Today I did cool. Characters, chars. Finish the line with this example. What's your favorite character? Try and blah blah blah. Let your please don't sound like just this. Yes,
Cool.
alphabetical. I'm going to do 5. Numerical. And I do yeah, I think I'm numerical.
Very epic.
Wait, why is because this one's alphabetical.
Mhm.
Yeah. Cool. Primitive types 3.
I'm not done.
Ah, you're right. Whoa. Creating an array with at least 100 elements to the line. Oops. Where the question mark is. Wait, is there an easy way to do?
No, there's no easy way. You just have to type 1, 2, 3, 4.
What's the easy way?
So it actually says it wants an array specifically, not a vec.
Oh, they're the same thing.
No. So an array is like an array in C.
Right.
Compile time, static size, not growable, not shrinkable.
Right. Okay. Whereas vec is like Python list.
Correct.
Right. Cool. Oh. What?
Have you seen array syntax before?
I don't believe so.
So it's just square brackets. You can put a value, and then a semicolon, and then how big your array should be.
You can also just not give it the size.
Yeah.
Yeah, and so that'll just be like an array of length 1, or if you have comma, 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 you can have, n elements.
So yeah.
Let's see.
Yeah.
That's It says you have to create an array with at least 100 elements.
That's not 100 yet?
Look, Shrey.
Oh. How do I make 100?
Look at the hint.
There's no shorthand. There's a shorthand which sometimes does not require you. Oh, right. I just do one. That's silly.
So that'll make 100 like strings of this 100 lots of the string 1, and now you have wow, that's a big array.
Oh,
Yeah,
I see.
Yeah,
I thought
yeah.
it just made like one and then like empty like C does.
yeah. So they look at the bonus. The bonus is actually really cool here. So they check, like the way they check if your array has 100 elements in it is they say if a.len is greater than or equal to 100, right?
Mhm.
So, but they don't actually like they didn't do that through a function or anything. They're just assuming that your a is going to be the type of an array, right?
Mhm.
So
Do this.
yeah, you actually could if you make it long enough. Yeah, that's probably good.
I am programmer.
Wow, that's a
we
big
tricked
array.
him. We got him.
Absolutely
this is
scammed him.
Cool. Oh wait, I gotta copy out the yeah. Print types 4. Oh, I don't know how to do slices. Get a slice of an array with a 12 virus to passes. I think it's like sorry, stop this monstrosity.
Probably, yeah, bring that back.
Like that? And maybe this shouldn't be there.
No, I mean, oh, you've got the right idea.
Is there a missing dot?
No, look at the
Okay.
error.
It wants the right F234. Right.
And ba-bang. Yeah.
Cool. Okay,
So
there's that.
basically, you can almost sort of think of a vec to a slice is the same as a string, like capital S string to a ref stir is the same as a vec to a slice.
String to throws a vec to a slice. Right. Okay, that makes sense.
So the vec or the slice or the capital S string can be like changed, like made bigger, made smaller, blah blah blah. Whereas a ref stir or a slice in this case, which is really just a ref square brackets, is a pointer, like it's a reference to somewhere in that list or
Right.
string or whatever,
So it's not a copy.
and also a length.
Right. So it's not a copy. Like slices. Are a
No,
copy.
So that slice is actually a borrow of your array. It's a reference into your array with a particular length.
Wait. So does that mean that if it's a borrow, can I not use like if I did print line of I don't know a of 3?
That will be
Isn't-
fine. There's nothing
isn't-
wrong with borrowing something twice.
Oh really? I thought that was the whole.
Mutable borrow, but go on.
Yeah, okay. There's nothing wrong with 2 immutable borrows. However, you can make it break, Shrey.
Yep.
Yep, just moves on. You can make it break if you put something between line 11, or like on line 12 essentially.
Mm.
Again, you can have 2 immutable borrows to something, and that's perfectly fine.
Oh, right. Nope. Do that.
Okay, this is a very weird case. You've made your reference mutable. You haven't taken a mutable reference.
How do you do a mute ref?
Ref mute.
And mut.
Oh.
Yeah, ref mute, yeah. And now you get the big borrow checker error.
Right.
The angry evil borrow checker.
And in that case, you just delete your code.
Yes, that's how we solve the borrow checker. That's how we appease it. And the reason that actually is important that causes an error is you can imagine if you mutably borrowed your original thing that you had. Let's say it was a vec. You mutably borrowed it, and then you shrunk it.
Yeah.
Then the thing that was referencing it before and said there was like 5 things there is going to go, yeah, blah, 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 uninitialized memory, someone else's crap over here, like, and then you get undefined behavior. So that's why.
Destructure the cat tuple. Oh, I can do this. I know how to do this.
Ooh, tuples. Nice.
This is just like Python.
Almost.
It's not like Python.
It's almost like Python. Oh, look at the compiler error. That's so good.
The bracket. Yeah. Yes. It's a worse version of Python. You're right.
Yes, true.
Kidding, Borojeka. Please don't harm me.
I think it makes sense like this because it's actually like that pattern is consistent in Rust.
Yeah. Cool. Indexing tuple. Can I just go numbers of 1? Or is it going to complain?
Oh my god, the compiler's too nice.
Oh, I hate this. I remember the first time I saw it and I hated it.
Yeah. You actually, honestly, it's almost one of those, like, you know, the whole Guido, our lambda syntax is crap because I don't like lambdas.
Yeah.
Honestly, that kind of works in this case where it's like you don't generally want to be indexing into a tuple anyway. Usually the better option is to
Make it out.
Yeah, is to pattern match it out or you know, things along those lines. So because it's clearer that way regardless.
Cool. Structs 1.
Structs.
So we've done prototypes, semantics variables, quiz 1, functions if, conversions, structs. I'm not going to read the readme. It's
Sure.
a bit dangerous like that. Oh boy. Something goes here. What?
Okay.
You said XG struct.
So there's color classic struct, color tuple struct, and unit struct.
Right. The name of the hex. Name is going to be a string and color is going to be hex. Is it not spelled correctly? No, it's just hex though. What am I doing? It's also a string, right?
Is stir a type? Stir is a type.
Your ref stir?
This
You
is
don't own it?
just okay. Yeah, so that's going to be the problem is if you declare a reference inside your struct, then it's going to want to like know, well, how long is this reference going to live for? Or like which reference is sort of which lifetime. You can get around it. There's a nice cheat code. If you go back to ref stir again, the nice cheat code is you can actually specifically annotate the lifetime of that reference.
Like this?
Yeah, it's on the right track where the single quote and then then an identifier or whatever, it's like a lifetime identifier. We usually say like tick A or tick B or whatever. There's a very special lifetime called tick static, which is like this reference will live as long as it needs to. Like however long you need it to live, it will.
Okay.
It's
so we're going to use strings.
No. But because you're only using constant strings there. They're baked into the binary, therefore they'll live forever. So you would actually write this as ref tick static space stir. So this is saying a reference to a string that will live as long as it needs to, and then you don't need to do anything special in your struct.
But then why would you not always just have this? Because then
because your reference.
If you can specify lives as long as it needs to.
Because not all variables live forever. Like if I created a string that was heap allocated after references that, that would not have static lifetime, and so you could not use compile would be using that.
Right. Okay. So it's assuming that you don't touch it.
Yeah.
Yeah. Okay.
So the unstatic that means something that lives at least as long as forever.
Yeah. Okay. Cool. Yeah. That at least makes sense. I'm just gonna do string, otherwise I'm gonna forget about this stuff later.
Okay, it'll just make your instantiation a little more annoying, but that's fine.
Is there a lifetimes thing in here? No, there's not. There's threads. There's no lifetimes.
The threads one is fun.
Cool. What is it? So we want to do. How do we do this? We do. What's the struct name? Is it with brackets?
Mm-hmm.
Name is string from green, and hex is string from that.
This may not pass
Interesting.
because look at the assertions.
No.
You can probably, honestly, you can do the trick I said just to like, because we're just playing this. So just change the assert eeks to say assert eek ref star green dot name.
No, that does work.
No, it doesn't compile. It's not testing your code yet because it doesn't compile. We can do it at the end.
Wait.
We can do it at the end.
Okay. We'll do it later.
Mm-hmm.
Goodbye to do. Goodbye to you as well. Cool. This wants. Wait. Why is it? What? Why is it in curly brackets?
There's 3 types of structs. There's like field structs, like the brace named field structs. There's tuple structs, where there's like the fields are basically unnamed. It's just like a struct attached to like a tuple. And there's unit structs, which have no, like, they don't contain any data.
Oh, why is it so white?
That is quite bright.
I can't change it. Tuple structs. Tuples are named, but the fields don't. They declare the struct keyword in the delivery tuple. Right. So I assume index of 0, 1, 2, or 1, 2, 3, or whatnot.
Yeah. Or you'd pattern match it out. Which is what they've done there.
What?
Yeah, that's the same as, think of it as like a tuple that you're destructuring, like in Python. That's why I said the syntax makes sense, because it's consistent in Rust.
How would you do 2 things though? It's like
Integer length, comma, integer foo.
and he'll be the same with comma, or what?
No, that'd be length is a tuple struct.
Oh, right, okay. Yeah. Cool, okay. What does it want to have? All structs, green at 0, green at 1. Right, cool. So I'm just going to steal this, and then I'm going to... Why is it not giving me suggestions?
Well, no, your Rust analyzer might be doing something a bit weird.
I need to let me use editor properly. Jeez. Cool, and this needs to be... Do I put anything here, or is just... Oh, wait. Just this?
Yeah, the things that the struct contains needs to go in the tuple there. Cool. And now you have your unit struct. So a unit struct is basically equivalent to the unit type, where it contains no data, it's 0 sized. Yeah. Think about it. You instantiate a... Oh, I'm angry that works. You don't... Okay, so you instantiate a brace struct with braces, a tuple struct with parentheses, unit struct, yeah, you don't need anything. I'm assuming that's what you were getting at there.
Yeah.
So you can just say unit struct, and that will actually instantiate you a unit struct. And... Oh, the test pass. Cool. Nice, so it actually infers it, which is handy. I suppose the assert eq must deref. Interesting. Or like the dot behavior.
How does this work?
Which one?
This message equals to...
Message equals format unit. So they've derived debug on unit struct, which will just
Right.
print out the name of the thing, and that's formatting it with the debug formatter.
Yeah, my Rust analyzer is broken. I can't even like control click to go to the definition.
Yeah, that's.
Which is painful. Alright. Structs. I just literally do it text fast. Okay, we've got a order struct, try debug name, year, made by, and blah. We couldn't create an order. Wouldn't this be where we usually like import like order and we just do like function or something?
Yeah.
Usually happens.
Yeah, 100%.
Right.
Just to put it in the right namespace, right? Like it's sort of attached to the like namespace per se of the struct, so you don't get it lost.
To do create an order using update syntax and template above. Update syntax that we don't know.
It's just updating the fields inside a struct. X, point.x equals blah or whatever. Oh! Is this? Oh, yeah, okay. True.
Oh, it's like JavaScript.
Yeah, it is. Yeah, it's like the spread operator.
Yeah. Cool. Oh my gosh, do we have to do this? Order template equals to name. What was the original stuff? Are they all wrong? 20 false true.
Hey, and look, most of these, the only things they want you to change is the count and the name.
Name equals string from Hacker and Rust. Count equals to 1, comma, dot, order, template. That does not like me.
Yeah, there's a few issues here.
Did I miss the syntax? Probably. Oh, right. Yes, that makes sense. Okay, let's do that then. That is, yes. Oops. Still doesn't like me because order template. I'm overriding.
Let the compiler help. Like it actually is a really good compiler. Like on the left hand side.
Yeah, this one is not helping. Name blah blah. How do we have to put a string in without path? What?
Hang on. Look at the help. Look at what it's highlighting.
Struct with a body without path.
Look at the help notice. Yeah. See, it literally tells you what to do.
What's the name of the struct? Order. If it's expected semicolon, that makes sense. It does expect a semicolon. And structure, I think it's no field name and type. What?
You need to create your order.
Oh, right. That's on function. Why is it saying on function? Oh, because your order is also a function, so it's referencing it.
That's unfortunate.
Why does it default to like? How does it even see that? Shouldn't that be like out of scope?
No. You can have functions.
Yeah, but like, I shouldn't. Oh no, yeah, that makes sense. Yeah, okay. Your order, fine. Oh my gosh. Ingar the 10th assignment.
Hang on, think about it.
Mute point.
No, don't. You don't add the mute there.
Can I
You're declaring a new variable, right?
Yeah.
How do you declare a new variable in Rust?
Oh,
Yeah.
why didn't it say that?
Because they are doing it slightly differently. They're actually like mutating their struct.
No, but like the error message, look at it.
Yeah, it says invalid left-hand side of assignment.
Pointing here.
Because the reason it's upset is because your order actually it's a function and it's trying to assign to the function, and it's like it's that same. They probably should have named it something else. Yay!
Alright, number 3.
Last structs exercise.
Oh, I bet I have to do a quiz after this, don't I? Diversive logic. This says we have to find the package struct and we'll test the multi-test struct. Make the code compiler test pass. If you have issues, get hints. Okay. Package, country, recipient. Input package near. Something goes here. What goes here? Something goes here, something goes here. Should panic, okay. So it's in panic. Lol. Okay, next part. Is international, probably gets a boolean. And is was it get fees? Fees is a fees isn't part of the package, okay. It just calculates it, I assume, given the order. Cool. Secondary blah blah package blah.
So it's trying to check if it's going across the country border.
I'm trying to check how I check that.
Well, look at what you have in the struct.
Send country, receiving country. Oh, they're not the same. True. But is it international if they're neighboring countries? Time to implement a graph database of all
Yeah,
the
there we
countries.
go, yeah. Rustlings.
Clearly, this is the most efficient solution. Oh my gosh, I'm getting spammed with Discord stuff from a server that I muted. Give me a sec. Mute channel forever. Cool. If self dot recipient country. Oh wait, I can just do country equals self dot sender country.
Almost.
Right. Does that not work?
It's semantically, like, according to the compiler, it's correct.
Oh.
Yeah, there you go.
Cool. Get fees. How does the fees work?
I have no idea. Oh. There you go. You get to decide how the fees work. Yeah, I was waiting for you to do that.
Oh wait, it's not. It's 3.
Huh?
Damn it. Well, it's...
Oh, you're right. You're right, yeah.
Damn, I was just gonna be like, oh, I should have done 0. And then it's like, get fees, return 0.
Okay.
3 times cents per gram.
Not quite.
Go transfer fees.
3
What's the
times
rest?
cents per gram.
Oh, lol. Why is it... self dot weight times 6.
Yeah, there you go. And this should pass, I imagine. Epic.
Yay.
So there's actually, before you move on, there's a Haskell-ism that is also a Rust-ism in this case with the first function you wrote, the new function,
Yep.
where it has weight in grams. If weight in grams is less than or equal to 0, there is technically still a type for this. The Haskell quote here is make illegal what is it? Make illegal states unrepresentable. Is that the correct quote? It's probably close enough.
Yeah.
And in that case, like, this is where you would almost certainly be reaching for a U32 because they don't want, but it's also saying equal to 0 is also like a bad type and should be unrepresentable. You could technically use the Rust type non-zero. You can do non-zero U32. And that would then make...
Oh, yeah.
That weight in grams, you could remove that check because it would be unrepresentable. Because panics are usually not very good.
Cool. Someone asked a question in voice chat was like, is Rust actually used anywhere? And I was like, yes, the same way that C is used everywhere, and more as well, right?
It's not... It's like... You could make an argument that Rust very well may be catching up to how much C is used on a sort of day-to-day basis these days. But in terms of like overall amount of code written, like C would blow Rust out of the water, and probably many, many other languages any day.
Also because C's got a 50 head start.
But like C and Rust aren't really direct competitors. Like there's definitely a big overlap. But for example, I don't think things like a lot of places where you'd really want to use C.
C and Rust are direct competitors. Anywhere you use C, you could be using Rust.
Yeah, but
and there is basically no way you could use C that Rust wouldn't.
If only for compatibility reasons, Rust isn't really a direct... Like, there's a lot of places where still C just really makes the most sense and Rust can't compete.
I don't think that's true.
Okay, that's fair.
Like, things that would be an unfair comparison, I think, like, the common comparison which happens a lot is Rust and Go, which do target...
Yeah, for sure. Yeah.
But the Rust is directly targeting use cases where C...
I would have argued C++.
Yes, but C is also in the exact same plus. C++ is a direct to C.
Yeah, I think for the most part it is, but the part where I disagree is like, I think there are still certain specifications where that you really are reaching for C as opposed to other languages. Like
but there is no actual use case where Rust can't compete with C.
Yeah, I do agree with you. Like, I know, from using a lot of Rust and using a lot of C, I do agree with you. I'm trying to find the right way to verbalize that. I just don't... I think there's some spots where Rust, although it may be a perfectly fine competitor and can do the same things, it's simply not going to be used in those places.
But that's not true.
Okay.
Anywhere C has been used, Rust is already being.
Yeah. But for example, I don't think Rust is going to... Yeah, that's a fair point. Yeah, fair enough.
So Ollie asked if could Rust be taught in 151? And I was like, yeah, it could. Like,
Yeah.
I don't think it should, but it could.
That's not the point of 1511, but like,
Yeah.
we taught 1511 in Haskell at one point.
Yeah. Cool. Right. So we are going to move on to the next one, which is enums.
Some types, baby.
Some types aren't real; they can't hurt you.
Some types should be in every language.
I don't know how to do enums, so I'm just gonna assume that it's like quit, comma, echo, comma, move, comma, change, because this makes the most logical sense to me as an enum to be described as. Yes.
Amazing.
To do. No more to do. I was gonna say, if it's anything else but this, I'm gonna be annoyed.
Yeah, that's fair. That's fair.
I suppose there could be one or two other ways to do it that would make sense, but this is like...
Yeah, that makes the most sense for Rust.
Yeah. Define the variants used below.
Hmm.
Right. Move of. What the heck? What? What? Is move a struct?
There's structs can be like named field structs, tuple structs, or unit structs, and enums act similarly.
Does that work? Probably. Echo is going to be a string. Probably this is email syntax. We'll find out. Oh, I should move up. No. Move should be of that, right? No? I guess not. I don't know, we'll find out. Echo string change color of I32, I32, I32. Oh my gosh, I'm a genius.
Yeah, it just works.
Huh.
It's very epic. Yeah, so you don't need you need the colons for the names, like inside the move variant you have X colon, Y colon, but you don't need it before the brace.
Before the brace. What? So I can do this. What? This doesn't make sense. But you say I can do it this.
No. So I'm saying you don't need the because you're trying to put a colon after the word move.
Oh yeah, that was a typo.
Yeah.
Okay. Cool. Enums 3. To do. Implement based on usage below. I'm gonna have an enum of like. I am. Where is it? Where are we using?
Ooh.
Match expression. No, thank you. Message change colors. Oh, I'm just gonna copy one from the.
Yeah, that seems fair.
Right.
And now you just introduce. Oh, that's so cool. Yep.
It's like
What are you matching?
message dot message dot move on something. Is that how you do it?
Not quite. So first, the syntax you're getting a bit muddled here. So
Yeah,
you need to you need to match something. So that's good. Match message. Then you've almost got the sort of variant syntax right, but you like message. What's the lowercase m message there?
It's an enum.
Yeah, the variant itself comes from the type, if that makes sense. So.
Oh, I can't match to an enum?
Yeah, no, that's right. You just need to change that to capital M because the variant comes from the type, not necessarily the value.
Yeah.
And so you say message move. The equals greater than is correct, and then you just have to make sure that the move of blah matches what it should look like.
So I just do like can I pattern match again like this?
So it's a tuple variant, is it?
No, it's a struct variant.
So why have you matched it like a tuple?
Right.
Yeah. And you don't need to redeclare the types again. Like, it knows what the types are.
Oh, okay, true, right.
Yep.
And this will just destructure it, so I can
Correct.
put anything here.
Yeah,
Can I
yeah.
put anything that goes through like that?
No, because otherwise, it needs to be named.
That shouldn't work, actually. That would be silly. No, I call move position. Why is it not auto-completing? What is going on? I don't want to type things.
Well, okay, yeah. What's the first parameter to move position?
Oh, I don't know. Self. Can I just honestly just write self? Is that going to work? Find out.
The unified function calling syntax.
Yes. Fine.
That actually would work, but you would just need to namespace it. You would have to say state : move position self point xy. So you could do it if you want to. You don't have to use the dot syntax if you don't want to. And that's why I said unified function calling syntax, because that's the special name for it.
Right. 65. Selected tuple. Found structure and message move. Wait. This should be allowed, right? Oh, once they're doing an else or something, right? Wait, no, this. Why is this allowed?
Mismatch type. Hang on.
Shouldn't this be
So hang on. We're getting the first. So the other errors look okay. The first error: expected function tuple struct or tuple variant found struct variant message move on line. It's defined on line 7. It's used on line 65. Move of a point. Your move variant probably doesn't take a point.
Right, okay.
So it is actually a tuple variant, a tuple point is a type.
Yeah, so can't I just make a new struct? Oh, right, no, that's, yeah.
Perfect. Yeah, there you go. And then you'll have to update your match.
Oh, how do I, what the heck, move a point?
It knows the type,
Right.
so you can just call it whatever you want. Actually, I'd probably call it lowercase p point, but yeah, I suppose that works. You can probably destructure the point at the same time, but obviously that makes no sense for this in this case because you're about to use the point again there. Cool.
Do I comma or do I just leave it?
Yeah, you don't need if you don't necessarily need to make your match a block. So you've said like arrow braces.
Right.
It can just be a single expression. If you do a single expression, then you do need a comma. If you do a block, you don't need a comma.
Right, okay. Message put should be,
In this case, I would say try doing this without the block. Just for funsies. Not a semicolon. Comma. Epic.
message, echo, string, yes, so, why does not like that?
Compare it to the line above.
Oh my gosh.
Yeah.
Look at this bad error message. Exactly one of
Okay.
blah 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 blah. It wanted none of those things. That's my second compiler bug today, Zach.
Yeah.
Rust bad confirmed. Oh no, chat is going off. HTTP very quickly, very abstract, blah blah. Haskell, mutability, Haskell,
Okay,
times,
yeah.
blah blah. There's I can get like university courses in general
Yeah.
and stuff. Cool. What's the next one? Change color. A, B, C.
All right.
Oh, it was a tuple?
Oh, it does want a tuple. Yes. Yeah. Cool.
Huh?
Let's see. Expected U8 found 32. Okay. No, don't as it. Don't as it. Don't.
It wants a U8. I'll give it a U8.
You can just update the tuple variant. Like, why you put I32s? Yeah, you're gonna have to do it anyway, I think.
Alright, fine.
Now you have U8s as U8s.
Extra safe. I pride myself on safety.
Your types have been doubly checked. All right.
Expected 3 argument.
Line 69.
Oh, once.
Yeah, you need to update your variant.
That's so annoying.
Yeah, it's a bit weird that they've done it like that. You'll have to change your match as well because you've updated your enum. And in fact, actually, you don't notice how you're unwrapping the tuple, then you're rewrapping the tuple.
Yeah. Oh, could I just like match on something?
Yeah. Yeah, and then that'll work. See, why wait for PEP 768 or whatever it is when we already have this?
Oh, I'm so excited for Python matching. It's gonna be so good.
Why worry about going to be
That's
so
what you
good?
have here.
Yeah. Why worry about going to be so good when it already is so good?
I'm excited for high current types in my Python. If it ever happens. If it ever happens.
I'm excited for not higher kind of
High current
types,
types in Rust?
generic associated types in Rust.
When are we doing high current types in Rust?
At least
Associated types will be,
at least after we get
What's
generic
that?
associated types. Yeah, exactly. Yeah.
and it'll give you most of the useful things.
Yeah.
Goodbye to do. I am done. Quiz time?
Is it?
Not a quiz time. Wait, what? Modules. Oh, can we skip modules? Back.
I don't know how to skip things. Oh, this looks pretty simple.
Okay, sure. Yeah. Sure,
I
this is
shouldn't need to make the mod pub.
cool. Sell fruit as fruit. Okay, wait.
Yeah.
What?
Okay, so this is a really interesting thing. When you're writing a library, let me show you Mipsy. Just to, not for any sort of
Oh,
useful use, just to brag, basically.
show us to a form.
So, yeah, okay. In Mipsy library, right. I think this actually does have a couple functions in it for, whatever reason. But it has a lot of these pub use, right? So we know use is sort of like import in Rust. So, I say I use this because I'm going to use it, but clearly there's not that much code here and there's a lot more imports than are probably going to be used. This sort of idea of pub use is a way of like exposing specific things out of a library. So I want people to be able to see the Mipsy result type, Mipsy error, compiler, blah, blah, blah. So I say import it for me, and then the pub use is sort of like make that import public. It's almost like re-exporting that import for other people to use. So then they'll just use like Mipsy : Mipsy result, or Mipsy : instruction set. And that's what they're sort of doing on line 7 and 8.
Right.
So I tend to do this a lot myself. Generally, I'll have like a module that has one type in it that I effectively want to be public, and then there's a whole bunch of other types that are. And it's not worth the user of this library having to go to that module to just get that one type, re-export the type in the parent. And so
Right.
when you look at the library, you don't really have any submodules when you using the library externally, because everything is in the root. But it means that the actual implementation is a lot cleaner. You still have things split up into a lot of different files.
Right. So, what is a private constant import? Importing, fruit, which is this, which is this. Public, not public.
So, no, don't need to make the module public.
Okay, but then why is it claiming it's private?
Right, so that's doing the whole re-export thing I was just talking about, the pub use. So what we're saying is grab self fruits
right.
pair as
Yeah.
fruit and then make that public.
Kind of. Is it still like I did this?
No, I guess not. That was interesting to see. But you get these. You can't make something public if you can access private types from it. It's this it makes sense. So in this case,
Yeah.
you're trying to export a private type and it's not happy.
It is angry. Is the rustc package the one I want from Linux? Is it rustc or cargo? Because that's.
What you want is rust up.
Oh, sorry, rust up. Yeah.
So there's the three. So rust C, cargo, rust up. Rust C is literally like the base compiler. Like I will take a .rs file or a few of them and I'll rust C blah blah and it generates me a binary, sort of like Clang or GCC. Cargo is a package management system for Rust programs, and Rust up allows you to have multiple different Rust tool chains installed. So Rust toolchain includes, Rust C, Cargo, Clippy, Rust format, all these different sort of things that are needed for an install of Rust, and it lets you have many different versions of it. It lets you have the stable Rust toolchain, the nightly version, the beta, and so it lets you manage them all. So just go to rustup.sh. Yeah, rustup is the mothership, sure. So you go to rustup.sh, there's a installation thing there, and then whenever you want to update Rust to the latest version, update your Rust C, your Cargo, your Clippy, all those things, you just do rustup update, and so it's all nice and sorted for you.
Zach, look at the Rust meme in memes.
In memes?
It's the Greek semicolon one.
What?
It's the one with the Greek semicolon.
I don't see. Where is memes?
Misk.
Oh, Misk. Oh, I have that closed. I don't see that. Oh, memes. Oops.
Zach is now discovering the use of memes.
Yeah, replace the semicolon with a Greek question mark in your friend's JavaScript. Yeah, pathetic. It's very true.
You should post all your Rust memes that you have into the chat after tonight's stream.
Yes, I have a big stockpile of them.
Literally a stockpile. I got sent 20 Rust memes the other day just out of the blue. Alright, the collections. Hashmap. We'll do Vec1, right? Oh, yeah.
No, that's really easy.
But oh, is the one something yet?
Mm-hmm.
Oh, the same thing.
Yeah. Bada bing, bada boom.
Each element in the vector is it's too naive to try and do this. No. Can't use this stuff.
I is a ref mute I32. There you go.
God. You
See?
can mutably iterate?
So it's a mutable borrow on the vec, and it returns you a mutable reference to each element inside the vec. Nothing wrong with that.
That's cool. The syntax looks terrible, but not terrible as in bad, just
I mean,
just look.
that is perfectly legal C.
Yeah, I know, but it still looks silly.
Yeah, I suppose so. But it's just, you have a reference, you're dereferencing it, and you're... Yeah.
No, it makes sense in why you...
Yeah.
Hash map, what the heck? Oh, cool, I can just steal this. Oh, wait, no, you can't.
Yeah.
Wait, I got a new hash map. Hash map.
Yeah. Yeah, nice.
Is that it? Don't I get any values?
No, it just starts as an empty hash map.
Put more fruits in your basket. That's going straight in my basket.
Oh, it doesn't care what they are. Alright, will that run it? Will it work? Oh no! Lazy. Why doesn't it work?
At least 3 types of fruit.
Yeah.
Huh?
What data type are you using, Shrey?
String T32.
Yeah, what's the name of the data type that would... It's a hash map. In case anyone else missed it.
Hey, you can have duplicates in hash maps.
Huh?
You can have duplicates, can't you? Collision.
Hash maps are... Well... That's a hash collision. That's two different values hashing to the same thing. Like, and that, like, so for anyone who doesn't know, hash maps are a key value data store. Like, one key, one value. Or, yeah. And so Shrey's just gone insert key, and it keeps overriding the same key. And now it's happy. I feel like you said that in the Discord chat, so like the stream wouldn't see, but the stream has
No,
the
the stream
Discord.
would see. I actually want to say it in recording.
Yeah,
People
yeah.
listen to the podcast are never going to know what I said.
It's true.
Because it's a very good podcast to listen to. Oh my gosh, why is this so much? Basket fruits.
This looks like a 1531 exercise.
Yeah. The key reference to the fruit, the variance is how many of the fruit there are. You have to put more than 11. What the? There are 3 types of fruits. Apple 4 already in basket. You're not allowed to insert any more of these fruits. Make a pass test.
Ooh.
Can you check type? How do I check if type? If fruit is. How do I check if it's like a mango?
There's a really
That's not a type though. That's a
it's a variant, but there's
You know what I mean? Yeah.
there's a really like kind of cool way to do this. You will only be able to, how do I say this? Imagine it was like a tuple variant or whatever. Yeah, we can do a match. Match is probably the right way to do this, but I want to show you like this cool little trick. Yeah, wait, it suggested the right thing before you got rid of the suggestion. Type if again. If space, yeah. If let, it's like this really cool thing. It works much better when you're unwrapping like a variant in the tuple. But yeah, you're getting it.
Yeah, I saw this. Yeah, because I saw this using errors, right? Yeah.
So the thing that comes after let, right, is normally a name, but actually, what you're putting there is a pattern, and there are 4 places for. I'd say there's 3 places where you can stick a pattern. So the obvious place that you can put a pattern is after match. So all of the cases for match are patterns. You match against a particular pattern. And do something when parts of that pattern are bound to variables. You can also with let match do a pattern match. So the thing that comes after let is a pattern. And
right.
In the case of if and while, the thing that comes after that could be a Boolean condition, but you can also have a fallible let, which is a let that matches a pattern, where the value could potentially match a different.
This is also a little cheaty, and one other place you can see patterns show up. Again, a little bit cheaty to say this, but macros is another one. So really common.
The third place I was actually going to say is function arguments of patterns.
How do I do an all on a pattern match?
So where you have a function and you give the names of all of the arguments that each of those arguments is actually a pattern rather than a variable. You can put patterns there as well.
Oh, really?
Yeah. There's 2 different kinds of patterns. So you have fallible patterns and infallible patterns. So an infallible pattern has to match every value of that type. So normal let and function arguments have to be infallible. They have to be able to match every possible value. Patterns used in match cases, if let and while let, can be fallible. They can potentially only match some of the possible values.
Right. Is there a way to do like a union or an or or something? No, an or in pattern match?
Yeah, you're literally doing it. You just have to provide something on the other end. Oh, this is in a if let. It's nightly.
Really? That's nightly for if let?
Yeah, if let with an or.
It's just a single pipe.
Yeah.
Why is that?
Hasn't completely landed yet. You also have to put on the right hand side of the equals tray. Like if let fruit banana equals what?
Oh.
The thing you're trying to match. Yeah.
How is that not in normal Rust?
It's just not stable yet.
I didn't think the syntax was specific to whether it was if let or let. Oh, if let or match, right?
Yeah.
It's just
Well.
whether or not it's fallible or infallible.
Stabilization of the feature.
Yeah. It's somewhat special case in the compiler right now, I suppose. But yeah, it's not stable yet.
Unless it was one of the things that got stabilized today.
What 152? I think Shrey's on 152.
Because there was some change to all patterns that was stabilized, like 3D.
Yeah, that's. Well, yeah, Shrey's on the latest. Well, you're not technically on the latest security version, but.
Yeah,
But he's on 152, and I think actually what you may be thinking of is that you can do in a match block. Yeah, in a match block you can do, like, for example, match like sum 2 bar 3, like 2 or 3.
Yeah.
And I think that's actually 153 that's coming.
Why is this? Why is the syntax for the pattern on iflet different to the one for match?
Iflet is the semantics of iflet are a bit weird. It was like there's weird hacks about it.
They shouldn't be different though.
Yeah, but in terms of the compiler, maybe it was code gen or something, or I don't know. There was something weird about it, and so there's some special cases with iflet. And yeah, to be clear, you should definitely be doing a match here.
Yeah, the only case you would use iflet is if you're only going to try and match.
Yeah.
And if you're trying to match multiple cases.
Yeah.
Yeah. Well, I thought there'd be an or, but there's not. Rust bad, I guess. I don't know.
You can do the or in the match.
Well.
Yeah, the match lets you do the or, and it's all nice and everything.
Okay. Well, hashmark 2 is done.
Oh, really?
Yeah,
nice.
It was that easy.
Cool.
Now what does it want me to do? Strings. I would rather not actually do strings.
Why, you don't like strings? Wait, this looks
Do
okay.
Shrey. Do strings. We want to see something.
Make me compile that change the function signature. Oh wait, can I just do?
Yeah, literally. This one's not too bad. Difference between a ref stir and a capital S string.
Got him. Too easy.
Yeet.
I'm very smart. Make me compile change the function signature. You can blah 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 blah. Cool. What is the issue? Expected ref string found string. Struct string. Why is it struct string?
Yay!
Because it's a struct. What was that?
Sorry, I just managed to get my Let's Encrypt set up so that it automatically.
Oh, good job. Oh, that's such a nightmare.
Another celebration.
Oh, I know that feel. Let's Encrypt, the auto update is really finicky.
I just had to write a script because my DNS provider doesn't have like a pre-made thing for updating it.
Oh. Cool. So this is the other way like round. You've got a string, which is What do you mean? Why is it a struct?
Why is a struct shouldn't be a type?
Yeah, that's what a type. A struct is a type.
I know, but it's yeah. I just don't like the wording of the message. That's all.
Wait, hang on. Oh wait, did you? I think you weren't meant to change the function definition.
I didn't.
Didn't you? Oh wait, what did you do?
I changed line. I changed line.
Wait, it says don't change this line.
No, it says try.
Oh my god.
You shouldn't.
Don't change it. Put it back. The compiler literally told you what to do. You have no excuses.
You can have your fun with Rust. Let's go.
See ya.
Oh, see you later. Oh, he's gone.
There you go. Oh, you know what I can do? I can do word 1 to GRE and 5. Does that work?
It actually will. Do it not as a slice. Okay, cool.
Too easy.
Wait, the treasure stuff? Oh,
Yeah.
that's a... Okay, time to clip it and ship it.
No. Leaked.
The Let's Encrypt challenges don't work. Solution
I
is
can't
to...
type, okay?
Yeah, I was right. You actually, it was a bug in Let's Encrypt. You actually have to go into the source code and remove the... It wouldn't do the different challenge because it thought that the first one was fine. But you have to like say,
It's two.
make it not know that challenge even exists. Oh, quiz!
Can I run? What the fuck?
Oh, interesting. Some are strings, some are ref stirs.
Why? No. Oh wait, you know I can brute force this.
No, come on, don't do that. Okay, Shrey, just which one? What do you think the first one is?
It's a string slice.
It's a ref stir. Second one.
I can't see the function signatures. So
Yeah, you should be able to. Just open up docs.rs and just like try out the documentation. Oh my god, docs.rust-lang.org. No, that's the wrong one. That's for like crates. Docs.rust-lang.org/std.
Why is it bad link?
Alright. 2_string.
2 string. It's string, I presume.
Well, hang on. What's it being called on? Go back to the code. I mean, and like, what's toString being called on?
A std string.
Like a ref stir, right? You just said the blue was a ref stir, so it's being two. So go back to the docs again, and you're looking for the toString function on the ref on like a stir type, right?
Yeah, which is this.
Yeah, that one.
Right. Returns a capital case string.
Yeah, so that literally is just a function to take a, let's say in this case a ref stir that, and it returns a heap allocated string, so you can then modify it and stuff. Yep. To owned.
I'm gonna guess that it's string slice because they're owned. Mismatched types.
Yeah, you've still got a lot of question marks.
Wait, to own is what?
Yeah, okay. So remember, a reference is a borrow, right?
Oh, right.
Yeah.
Right.
And an actual value is an owned value. Nice, where the dot into.
That's a terrible screenshot.
I'll be 100% honest.
Dot into.
That feels like there'd be conflicting implementations to
The
me.
definition of a dab is headbutting your elbow, okay? Don't blame me.
Imagine ditching half the stream and coming back just to roast my dad.
I know what this should be, but I thought into T for T was... Probably not. That doesn't really make much sense. Into is a trait.
What? Why?
Into is a function on a trait, and it's implemented for, well, stir in this case. You can look at the stir implementation, like stir into. You can search stir : into. Ooh.
Rust bad? Confirmed?
What's it being? That's... Oh, no.
I made compile it for me.
Stir into... That's interesting. I'm gonna have a look. That
No,
I was...
it's string slice.
Yeah. Wait.
Format. What is format term? Probably a string. Right. String from ref. String slice. Trim poly string.
Oh. Here, Shrey, take a break for a second. I've done my little investigation. So there's the into trait, which we were just talking about, and into, where can I show declaration? There we go. Trait into has one method, into and self, and produce a T. So I could implement into U32 for I32, and then that would turn an I32 into U32. Except it's weird because we couldn't find any implementation for stir into, right? But there is, I'm going to have to see if I can type this correctly. It would be like, let's look at from. There's another trait called from, which is sort of like the opposite. It takes it some sort of T and turns it into my value. And there is this very special thing here. Where am I looking? Probably down here. Here we go. Impl from. I guess it's going to be on the into page. My bad. So if I just go back to into again here, it'll say impl into u for t, where u is from of t. So it's saying that if you can turn a thing from that into that, then you can into the other way around. So if we look at string from, then that will take a ref string into a string. I wonder if there's a stir from. No. So it's getting the implementation from string from, and then, yeah. Interesting nightmare. Wait, that's correct. So string slice into. Interesting. See, usually people use into to convert a ref stir into a own string. So that's interesting that it ends up like that. What happens if you do call it with... Oh, you know what? Call it with string. Like, change string slice to string for nice weather into.
To string.
Yeah. And then run that. Yeah. Because... there you go. Here, it actually says it here. Into is reflexive, which means that into T for T is implemented, which is why I was like... I was surprised. I was like, it's not going to know which implementation to use, but it does because you're choosing the function, right? And you're saying that function needs a ref stir or that function needs a string. And so it goes, yeah, I can turn it into a ref stir or I can turn it into a string.
Oh, somebody... Ollie, did you ask for the instructions? Because I swear I saw you ask for instructions, but then the message disappeared.
It says yes. Maybe.
Oh, okay. I thought I was going crazy for a second.
Zach
yes,
Zach doesn't need Nitro for an HD stream because Zach is doing an HD stream to YouTube.
True.
For free.
But you could pay $6 a month, Zach, and you get animated emojis.
That's true. I could give away money for free. Oh wait, I need to go back to your screen. Sorry. I forgot
Linus
to
Torvalds
do
says
that.
nothing better than C. Is it? I don't know. I'm reading random. Someone posted a link about Linus saying that C is the best.
Yeah, fair. C is a good language.
Not bad.
All right.
Damn, wait, what? Oh, wait, what?
What? So that's...
Oh, I thought it was saying error in quiz 2.
No.
Error handling. Sack, man. I don't believe... Look, Python has it right. It's easy to ask for forgiveness and permission. So let's just delete these and move on.
I feel like it's going to have a big cry if you delete them.
I would try it, but
But I'm too scared.
this function refuses to generate text because blah 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 blah. Hiya. sum and is option guaranteed to be sum none?
Yeah, some or none.
So how are they getting an error? So what's the type where it's sum or error? Is that maybe? No, okay, maybe it doesn't exist. What did I do? Rust sum or error.
What's
Option?
So that's option is some or none. If you want, there's no sum or error, but there is okay or error.
Oh, that's
Dum dum dum.
I'll find out what it is by doing os.
Wait. Why don't you just go to the documentation and type okay?
Fine.
The documentation is actually good.
Result.
Wow. Scroll out, just look at the definition of result.
Result. Okay or error.
Yeah.
But then why? How can you do sum? Is sum okay?
Yeah.
Right. We love sum types. Get it? Because it's like
Ha ha ha.
sum types.
Epic pun.
I love all types. Cool. What was it called again? Result. Error.
Yeah, fair play.
I missed the opening quote. Okay.
There's something wrong here.
Result string. Oh, it has to be string or error string, or is it string or string? Check an enum result found option. Huh? Wait, this feels like it's something I should be doing.
Why are you doing a result of an option? So it's expecting.
Okay.
Yeah. Okay.
But I feel like this is not going to work for the test, because the test is expecting a sum.
Yes. Okay. I see why you're doing that. You'll have to modify the test. It says you'll need to.
That feels wrong, right?
It says you'll need to update what this test expects.
What? Silly, isn't it?
Yay.
I don't think you should be encouraged to pass tests by modifying the tests.
I mean, that's how I usually do it.
No, you just don't write them for MIPC, huh? Where's the MIPC tests?
I think there's one.
Maybe you should do the section on tests, Zach. Might be useful.
Function test. It works.
What is this?
Oh wow.
I don't read 3 paragraphs? What the heck?
Oh wait, there's not that much.
Can I apply result of by integer?
Wait, what do the tests say? Just read the tests. Test-driven development.
34 times 171. Plus 5 times... What? Oh my gosh, okay. Fine, I'll read just stupid documentation. All items has 5 tokens, and when you purchase a processing fee of 1 token, it's times 5 plus 1? Is 34... 34 times 5 plus 1. Oh, it is on C1, okay. Beep boop, invalid.
I'm actually not kidding, Shrey. I'm pretty sure you can do this whole exercise with 1 character. I'm not kidding.
Like this?
No.
No, you can't. I need to give it this thing, right?
What's the error type in this case?
Positive error.
Where's that come from?
There. How do I return a... What?
So this actually doesn't compile. It doesn't compile.
Okay. Can I multiply a result of blah by integer? for quantity.
Look at
Okay.
look at what's pointing at quantity as well. It actually says that. Yeah, there you go.
I'm a genius.
Okay, do you want to explain what's happening, Shrey? Because
Well, you see, Rust programmers are lazy, right? And rather than writing something like, error checking, to check like dot unwrap error or unwrap or else or something, to check if it unwraps correctly and it's an actual number, they have a default thing called question mark, which will attempt to unwrap it. If it doesn't, it'll produce an error which you implement on the type or something. I don't know. So therefore, for parsing error, it's always guaranteed to be this string.
so okay, the
Yeah, do you want to undo that?
so item quantity dot parse of I32 returns a result which will either be okay with the I32 that was successfully parsed, or it will be error with some parseInt error. That's just the type signature of that particular parse variant. So quantity, let quantity there, isn't actually an I32. It's not an integer. It's a result. It could be an integer. It's either okay an integer or it's an error with that parseInt error. You could manually match it. You could say let quantity equals match item quantity parse, and then say if it's okay of n or whatever, make it n. If it's error, then return that error back or whatever. But because our function total cost also returns a result of I32 or parseInt error, the thing that's most important here is that the error type of our function, which is parseInt error, and the error type of that parse function are compatible. Like, in fact, they're the exact same. We can just say question mark. And what that question mark means is if this happens to be that error variant, error with a parseInt error, return from this function immediately and make the return of this function be error of the specific error we got by calling parse. And again, it works because it type checks. The errors are compatible. But if it wasn't an error, if it was okay, then unwrap that successful value, which will be an I32 in this case, and put that in quantity. So that question mark actually changes the type of quantity from a result, I32 parseInt error, to just an I32. And it works because, the next line we're able to use it and go on like that, because if it wasn't actually an I32, if we didn't actually get the value out, then the function would have returned and we wouldn't be continuing to execute. So it's this really handy, like, unwrap it or return that error from our function. And like, if you look in MIPS or whatever, there's probably hundreds of question marks all over the place. It's very handy.
Yeah, really, I am not done. I'm probably going to do like one, finish errors and hurry head off because I need to go to bed soon.
Reasonable.
We get to the result as well, which is cool. The question mark operator can use the function returns result option. Right. Total cost. Total cost returns the result.
Using what I just said, can I use MIPSy to learn all my Rust? Yeah, definitely. So Shrey, using what I just said about the question mark operator that I'm sure you were astutely listening to, why is that not working on line 15?
It's a great question. Ollie, I'm sure you would love to answer this question.
There's a rule about when you can and can't use the question mark
Well,
operator.
you can't use a question operator in a function that returns the unit type, right? That would make no sense. So, therefore, we must make sure the function should return result or option to accept the question mark. So, total cost is returning. Why? What? Why is it erroring? I don't know. It's clearly returning a result, is it not? Oh, here it's not. Here it's going to error early.
Does Ollie want to help? Ollie, what do you think needs to be changed?
Got him.
Are you about to get schooled, Shrey? I really hope you are.
Ah,
Oh no! So sad. What about you, Oscar? Are you listening to what to the rules I said about the question mark operator? Let's see. Oscar's not even listening. Oh, I literally just heard him from like through.
Yes. Your name is Oscar, is it not?
He goes, oh.
The question mark operator. You said it only works in option type, right?
Well,
Mm.
I
Change the definition of the function that's returning the returning
But it
the
is returning a result.
a result. Question mark operator. Returning a result. Is the function? What are you passing the result? Where's the question mark operator? There it is.
Yeah.
Total cost. But that doesn't look. It's returning a result. Why are you passing it just like is it taking a result? Is
It doesn't need to get
Sorry,
any
this is
result.
function.
Returning a result here.
Oh yeah, so it's returning a result, and then. Oh, I see. Okay, yeah. It's a great question.
You've
You
satisfied.
need to like catch the error. I don't know.
Yeah, that's honestly that's on the right track. You've satisfied one of the constraints, which is the thing you question mark needs to be, something like a result or an option or a try type. And total cost does return a result, so it's a good candidate to use a question mark on. But the other constraint when you're using the question mark is that your function needs to return a compatible error type. Right? So on line 28, that question mark works because parse, the function, is a result I32 parseInt error, and parseInt error is compatible with that error type from your function, parseInt error. Since they're compatible, it can propagate that error by returning from the function.
Yeah, so it returns a parseInt error, right?
Okay. What is the function that question mark there is being used in? What's the, is it compatible?
Why wouldn't it be?
What function is that question mark being used in on line 15?
Total cost?
No.
Main.
It's being used in main.
Yeah.
What's main's return type?
Nothing?
Yeah, just unit, right?
Yeah.
What does the error message say?
Can I use the question mark in a function that returns unit?
So you can only use a question mark on something like an option or a result or whatever. The second constraint again is you can only use the question mark operator in a function that returns a compatible error type.
But why?
Okay.
Because it needs to be able to propagate that error upwards.
But why can't it do that? Like, why isn't this is it exactly the same as like unwrap? Error?
No, because
Right? Like, isn't this propagating saying unwrap it, otherwise error, and you've got the error, you know what type it's giving you, right?
Okay.
It's not giving you this sort of thing, so then why can't I just throw the error there?
what do you mean throw?
Oh, right. Why can't, I guess it can't really, I don't know. Okay, I think I see what you're getting at. Like, there's nowhere for it to go, or do anything.
Oh, okay. So to use the question mark operator is to have a result being returned. Same thing. So when your function that has a result being returned, it just returns the result of parseInt error instead. And if you can't do that, this is a specific type of error which I guess can't be just put in a normal context.
Yes, this function
Just in a result context.
See, Oscar explained it so well, Zach. What are you doing?
Yes. Very good. Very good. Very well done. So the fix is?
So the fix is to go. Isn't this the fix?
Well, no. Hang on. You're not meant to change. That's a question mark. Semicolon.
Wait, the fix is not to change that.
Yeah, don't change the code. No, that function's fine. There's no errors in total cost.
Well, the error's here.
Yeah, but don't change that line. Don't change that line.
What?
What?
If
No.
Rustlings hint.
Hang on. Cannot use.
Yeah.
Let me read it out to you. cannot use the question mark operator in a function that returns unit.
Wait, so I should actually just change the type to main. Surely
Is
that's
that
not
going to
allowed.
work?
Surely that's not allowed.
Generic parameters. That you just wrote like a tuple, a type in a tuple. Wow! Look at the error message.
Function trait main brackets. Oh right.
It actually is. That's so clever. It actually can tell. That it's like, hey, you should use angle brackets.
Expected enum result found.
Think of so. Okay, you're in this. Oh my god. You just get suckered. Almost.
Oh, true.
And voila.
That is stupid. Why am I able to?
It's actually.
Return, shouldn't main always return a number for like?
It's actually really good because look at this. Change your pretend user input to something that doesn't work, like foo or whatever. Like look at 8. No, why would you do that? Just change the variable. Look.
Right.
It actually it's really handy.
Oh. See, I didn't think that you could do like. It didn't occur to me that like non-integer return values from main were a thing.
Well, I mean,
like,
to be fair, they're like non-integer return values definitely were a thing because you've never used an integer return value from main in Rust. You've had a unit return value in main.
yeah, but I just assumed that was like C is like no return and is like implicit return 1 or return
Oh,
0.
okay. So
Right.
there's actually a few options of what you can return from main. You can return unit, you can return I32, you can return option, you can return result.
Mm.
I can't remember if there's anything else you can return. Rust return from main. Oops. Rust return value from main. Let's see.
Ollie, the way I understand it is that question mark will unwrap, or if it's unable to do that, it will return an error, right? So here, it breaks, right? So it returns an error, total cost. Total cost is a question mark, right? So then an error with a question mark is like, it will try to parse the error, which it can't, so it breaks, and so it returns it again, but main before had no type, right? So main has an implicit return type of the unit type. And so what it's saying is that, hey, your function is returning a result, but your function main has unit type, right? So we have to modify the type to accept a return of a result. And that's what Oscar was saying, whereas like, question mark will attempt to unwrap, and if it can't unwrap, it will instantly return an error. So here we attempt and we fail, so we return an error. That means this is trying to attempt to unwrap an error, and obviously you can't unwrap an error, so it errors when doing that. And then it tries to return it, now we return a result, and it's when we try to run it to something that's like silly, like not a number, it'll say main broke because of a parsing error that was returned. The kind was invalid digit. So it's just like, yeah.
So
yeah, the question mark doesn't have a return. The question mark is literally saying like.
No, the question mark does kind of have a return in it. He's right.
What do you mean have a return?
The question mark literally. Okay, you know what? I'm going to switch to my screen. I'm going to explain it very literally.
Do the comparison of the thing.
Like literally, very. Let's say we have function foo returns result of. I don't know. It doesn't matter. Unit and. Let's say the error can be a parse int error was fine. That came from use num parse int error. Great. Oop. And this can be bar. Right. So if we have like the string 3 parse into an I32. Like that, question mark, and then just like, yeah, that should be happy like that. Let's just make this return okay, okay for now. The other one's going to need to return okay as well. Just to make sure this should compile, rust c bar. No, it doesn't, because I need to do 3 dot pass. Like that. Main function not found. Sure. Okay. Okay, cool. So that compiles. Literally, oops. The exact same thing here. What this question mark actually like is syntactic sugar for is exactly this. It is, and I should really say let x equals that, right? That is quite literally just syntactic sugar for exactly this. Let x equals match 3.parse into an I32. OK of x goes to x. Error of e goes to return error of e. So there absolutely is a return inside a question mark operator. This is literally just sugar for this. And just to send the point home, Rust C, no, okay, fine. I need a semicolon on that binding. Rust C, and then it's happy.
Yep.
Okay.
Coolio.
Also, the answer, by the way, what can main return? I was wrong. It can return anything that implements the termination trait. So that can be a result, it can be unit, it can be the never type. Remember, that's a type that can never be constructed, so what it actually ends up meaning is your main will never return. It's like this handy little marker for it, which is pretty cool. And exit code, which looks like a type which can be success or failure.
Process exit 1 is also one. Something like that, right?
Yeah, but that's not a return value from main.
Okay, sure.
That's a separate function that takes a I32 and returns never, because it never, like, you can't get a value from exit because it never returns, because it exits the process. Very cool. Cool. Back to Shrey.
Why do they give me like 7 paragraphs to read? This is a big error exercise for the previous ones. You can do it. Thanks, Carol. Edit the read and validate function only. Don't create any errors that do not already exist. So many things are wrong. Read percent included IO error. Parsing input could produce a parse input error. Validating creation error, which is defined below. How to look at errors to one general error? There's one type.
Ooh.
What type goes where the question marks are, and how do I return that type from the body of the validate? Tossing in errors for hits. Right, so it wants us to fix errors, and then the creation error is find somewhere here.
So,
right.
Yeah, if it's negative or 0, that's bad.
Yes. Right.
Oh my god, are they expecting you to know dynamic dispatch? What?
Surely not. So I can just do question mark and no, that's not going to go. This one now. I read. Wait, where's the question mark?
I think they actually are expecting you to use dynamic dispatch, which we haven't learned yet. Let me just double check. Let me look at like Rustlings solutions. I'm going to cheat. Because I want to see if... Which one is this? Error is N.
Yes. I think this is anything that implements error, right?
Let me just check. Exercises, error handling, errors N. Okay, let's see what these two people did. Yeah, one used dynamic dispatch, the other person also used dynamic dispatch. Yeah. Okay. Oh, this gets into so many like rabbit holes.
Yeah, we'll just ignore it.
Yeah. Do you see what this is saying or no?
Expected enum blah found enum something else.
Yeah. What does positive non-zero integer : new return?
If only I could click on it, but I can't. New returns a creation error.
Yeah. So Yeah, and this is why we get into all these nasty like rabbit holes. Honestly, you were on, and so you know I'm just gonna let you keep messing this one around because yeah.
Okay, question mark is probably the answer here. Right. Expected blah blah because of return type. Expecting a result found struct positive. Oh, okay, sure. Let's be.
Cool. Dude, the help messages are so good.
Oh,
Crazy.
easy.
Yeah. It's such a huge explanation. It deserves its own 2-hour stream to explain
I'm
dynamic
looking at-
dispatch.
My understanding is that this is saying anything that implements the error, like is of type some error. I don't know.
No, you were right the first time. Anything that implements the error trait.
Right.
Um.
But this doesn't implement the error trait. Oh, it does.
Yeah. Um.
Okay.
But it's
No, but
it's.
I don't want to 3-hour talk for dynamic dispatch.
I'll just tell you what it's not. You know how in Java you can have like object. How do I say this? Like. Mm, God, this is really hard to try and like succinctly transfer. Like, okay, so shit. It's forget it. Yeah.
Wait, they were in generics. Not what's result 1?
Huh? Oh.
It says the next one's generics, not result 1.
Oh.
Whatever. There's only 3 for generics. This should be that bad, right? Like a subtype T. Damn it. Wait, what if you not found the scope? Isn't it generic type T? Can't I do that?
Well, yeah, but like, what if you just threw in T randomly in Java? Like, it wouldn't be particularly happy.
You get 6 compiler errors at once.
Yay!
Generics. I found that finds the straight entry value. Yeah,
So okay, right now it wraps only U32s. Rewrite it so it can wrap anything. Great. What's T? Oh my god, the Rust C is actually hacks.
I was about to do that. I was about to do it before Rusty did it, so I'm yeah.
Okay, well, you also didn't read what Rust C just told you, and now you've made it worse.
Fuck.
You literally get hacks and then you choose not to use them.
I'm balancing the game.
Yeah. Okay, read what it actually says.
Missing up type parameter.
Notice the help actually like points where it thinks things should be.
Oh, really?
I mean, it's like in Java. Java has class, like, you know, you do class foo of T. What have you done? Oh, okay. No. No. Get rid of that. So you were right the first time when you put, because you're implementing something on a wrapper of T, right?
Yeah.
But when you save this, it says it doesn't know what that T is. So you actually need to throw a T on the impl as well. You're saying implement for any T on wrapper of T. Does that make sense? Yeah.
What the heck is that?
Implement on any T, wrapper of T.
But why can't I say implement wrapper for any T
You just did.
without having the first T?
Well, what if you wanted to do? What if you wanted to implement on wrapper of string?
Then it's fine because string is a type T.
No. Okay, no. I mean, like, what? Go like make new lines, like on line 9. And what if you want to impl wrapper of string?
Just do the input and wrapper of string then.
Right. But how does Rust know whether the string is a generic parameter, like a T, or if it's an actual type, like string?
You presume that if it's got a concrete implementation, then you should go that, else fall back to the default implementation.
No, because if some dickhead comes along and makes a type called T, your code now breaks. It does the wrong thing.
Just ban the word T. No,
What
that's
if-
a bad solution.
What if you run out of letters? So you're saying implement generic over any T, wrapper of that T.
Okay, fine, you convince me. Huh? Failed?
Huh? This is the next one.
Oh.
Oh, it panics. Oh no, it's just an assertion panic. Damn it. I saw panicked and I was like
No,
excited.
Oh my god. Panics was no sort of problem with how I want to be alphabetical grades. This isn't alphabetical. What?
Well, A to F, like the
Okay, that's alphabetical.
letter grades.
Can I do... I can't do this, right?
No, you cannot.
How do I say blah blah blah? I don't want to be generic over any type. I want to be generic over 2 types. I forgot how to do generics. Plus generic 2 types.
I don't think you're gonna find 2 types. It's very interesting watching your like thought pattern though.
Any generic TOU, right? But I don't want that. I want specifics.
So
Generic.
we just actually went through this with the impl. You can implement something for a specific generic type, or a specific type on a generic, or you can implement it for like any generic, right?
Mm.
So you just because your report card is generic over some type T, it doesn't mean it's generic over every type T, if that makes sense.
Right. So I can just do string, or this is going to be already this is already I32, right?
Yeah, pretty much.
But do I need to do a double method print? This is for string voices.
It's a double, or F32, which is a float. Let's see.
Alphabetic numeric.
So how do they construct it? Make sure to change the grade here. This guy. Keck
Oh.
W. Papega. Wait, did we get rid of Papega? What the hell?
Oscar's a nitro. Oscar's a nitro. Bet.
Wait, I swear we had a Papega emoji. Where'd it go?
Yeah, Oscar's a nitro.
Bruh.
Yeah. Maybe you should stream on Oscar's account next time, Zach.
Wait, but we actually had it in CSE sock.
Did we?
Yeah.
You should have that.
Someone
I
removed.
am done. We did it. That makes sense.
I'm so
Find
sad.
any generic trait and then implement only the 2 specific ones. Cool. But this is dumb though, isn't it? Like, why would I? Isn't sure? Well, it's duplication of code for no reason. Like, is there not a way to do like string or like F32? Like, choice is bad, right?
What you could do is impl on. Well, okay, so this is more of a bad example, like, because you wouldn't really write things like this. Like, realistically, the only bound you have on the grade is that it can be displayed, right?
Mm-hmm.
Like, a string can be displayed in a format, an F32 can be displayed in a format, so anything that can be displayed in this case is perfectly fine as a grade, right?
Mm-hmm.
So what you can write is impl. So just add a new impl block with the same stuff.
It's using like where?
So you say
Alright.
impl t. Yep. Except this won't work. So delete the other impl blocks and then try and compile it, and Rust will tell you that it won't work, and it'll tell you why.
Because it doesn't work, like it's not displayable for some types, right?
Correct. Right? T cannot be formatted with the default formatter. And look at the help. You're close. You're on the right track. Look at the suggestion it gives you at the bottom.
Oh, that's also wait. Isn't there a where block as well?
Yeah. So you can write it this way first, and I'll show you how to write where. I like where. Where's good. Right. So this says impl for t for any t that implements the display trait. Impl report card of that t print blah blah. The way you do the where is after the t you just do, you don't have, I'll tell you how to format it, but after the t you do enter. You don't need to do an enter, but it's how it's nicely formatted. Where enter enter, and then on the line above put a tab, and then go t colon display. Or if display is not imported, you'd have to do std format display. And you wouldn't put the just to like Rust format you, no space before the colon, no space before the T on. Oh, you did it. Okay. Nice. Very speedy.
Maybe.
Yeah.
Okay, that doesn't answer my question though. What do I want it to do?
Well, that's what you just done. It's like.
Yeah, but this has floats. Okay, wait, no. This has integers. What if I don't want whole rates? What if I only want integers? Sorry, what if I only want floats? I never want a grade of 3. I want 3.0.
You can say. Oh.
You can fuck off because Ross doesn't like you.
I'm thinking of all these really. Let me show you a really garbage way you could do this. This is like. Can you copy paste the code somewhere, Shrey?
Yeah.
Just so I can like quickly access what you have.
Oh, that's not you.
I don't need a playground. I have terminal. Terminal.
This is the entire thing in plain text.
Where'd you put it? Oh, you
Yes.
sent it here. Okay, thank you.
Because it wouldn't let me format it to code.
Oh my god. Oh wait, no, it's not that bad. I thought it was. I thought it removed all the new lines and spaces. Okay. Good. There's one really dodgy way you can do this. I'm imagining. So I forget how to use Vim when I haven't used it for a while. There we go. Perfect. Advanced Vim user. You can bring this back, get rid of these, and write something like this. Trait valid grade, impl valid grade for F32, impl valid grade for string, impl t report card where t is a valid grade, and make valid grade require. Oops. Make valid grade require std format display.
Oh.
This would work, I think. What do they call this? Report. For F32, I need to basically just put like an empty block here. Main function not found. Semicolons not needed because I put braces there, and then just like fn main. There you go.
Huh. So there's no way to do like or types, but you don't need to when you can just make your own sort of types, which are traits, right?
Yep.
Traits are just types?
Traits are
I
like
haven't got that.
Java
I haven't got
interfaces.
traits.
Traits are Java interfaces.
Right. I think I only got
Haskell classes.
inline assembly.
Yeah.
What?
Yeah.
What? Okay. Isn't there a book on unsafe Rust?
Yeah. The Rustonomicon.
That's fun.
If you only ever want Mark to be U32, can you just set its type to U32 instead of T? Yeah, 100%, for sure. Rust also does a thing called monomorphization. So
Yes.
in Java, if you have generic types, they get erased at runtime. Well, I guess at compile time. So by the time you reach runtime, they've been erased. What that functionally means is like anytime you use like some T in Java, the compiler will do its very best to check that the way you're using the T is okay and safe. And then at runtime, like when it actually finishes compiling it, it just turns all your T's into like any object. It like completely erases the idea of its type. Like completely. And that has its own issues. In fact, even sometimes the compiler isn't actually good enough to verify that the types are all safe and happy. And so it'll be like, yeah, that generic code's good when it's not. And it'll just magically work at runtime because there actually are no types and things get really weird. In Rust, you have something called monomorphization, which means it will keep track of what different T's are used for like a certain T. So if I go back to my screen here, report card of T is used here. Well, not. It's like the print technically is used, which is here. It's used here with a T is a F32, and it's used here where T is a string. So Rust will actually generate, or Rust C will generate one function print where, not really. It'll generate two structs. It'll generate one struct report card where T is a F32, and it'll generate another struct report card where T is a string. And then it'll generate one method print where for the F32, one method print for the string, and then it'll decide which one to do at runtime. Sorry, not runtime, compile time. It'll go, this one goes that one, this one goes that one. So
what I was trying to do was make sure that before the code... Oh, let me get back to the code. The code was saying that report card is generic over any trait T, right? And that would only work if I can display. So if I had a float, it would work fine. But if I wanted to be, a crazy programmer, I'm like, I hate floats, I only want integers and strings, then it would not let me do it unless I did what Zach was talking about, which is like specify using some weird stuff. Yes. I was just trying to be extra specific about my generics, essentially. Cool.
Yeah, Shrey wanted to restrict it further than it needed to be.
Option. Oh, I do like option.
Options are great. Maybe monad is the best.
It's not a monad. Rust doesn't have monads. Don't fool yourself.
God damn it, Shrey.
You wish Rust had monads.
It has and then. They're just...
It has monadic behaviors.
Yeah, you're right.
I learned in 3141.
You're actually, as much as I hate to admit it, you're completely right. It just doesn't have, the type system isn't powerful enough to have everything in higher kind of types. It doesn't have higher kind of types.
Function name, print number, 16, option of sum. What?
What?
Oh, it's yeah. It's an array.
It's an yep.
Bye, Anthony.
Generics are just like parameters, but for types instead. Exactly. In fact, in almost every single language, that is like not technically true, but it feels true. In really purely typed languages, like purely typed, like functional style languages like Haskell, where you have these crazy big type systems, that is exactly what a generic is. It's a type, it's a parameter for a type. So it's actually like being able to see it like that. Not only is it like Yes, it's impressive. It's the right definition. It's literally like the very core exact definition in like the most pure of languages. So yes, that is exactly what it is.
What is wrong at the moment? So number to add equals to u16 blah blah blah. I don't really care. They just convert it into an option, and then numbers of blah equals to the option. So why is it complaining?
Ooh. Use of possibly uninitialized numbers.
So numbers is not uninitialized. So is it a type of 5? Yeah. Oh, it does not take a type. Does it take a value?
So I'm actually low-key surprised that it's... Yeah, that's... You could do that, but there's probably a better thing you can do instead of sum 3. Like, you're using an option. What would you initialize the option
You're
as?
saying it's possibly some none, right? What?
Wait. Yeah, okay, right. So, like, okay. I would probably initialize it as none, is what I was going to say. Like, right?
And why does that work and option doesn't?
Oh, okay, right. So this is actually, it's declaring an uninitialized array. It says let mute numbers, which is of type option U16, 5 of them.
Oh, right.
It's not the like equals an array of this, right?
Right.
So if you want to do like 5 values, which makes perfect sense, you would need to set it to that, as opposed to saying that's the type.
I don't understand why this is bad though, because we're just, I mean, yeah.
Yeah, you are assigning to it, so it should be fine, but like it's not.
How do I make it initialize to none? Do I do this?
Yeah, but again, that's in your type specification there. Like, let me numbers is of type this, and none is a value.
How do I initialize it then?
You've done array initialization already. It's you equals. It basically looks like the exact same thing, but
Oh, you're right.
Yeah.
This is the type. Yeah, it's
that's what I'm saying. Yeah,
Yeah.
but not a comma.
It's semicolon.
And I'm interested to see if you actually need the type annotation or not, because it may be able to infer that it's an option of U16 from the number to add, but maybe not. Let's see. No, it does. So, because it doesn't actually know what the type of numbers is from that, just like none. If it's just none, it could be an option of anything,
Yeah.
any t. But because on line 21 you have numbers equals some number to add, and it sees that numbers to add is U16, it goes dung 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 dung. That must be a array of 5 option of U16s, and it figures that all out for you. It's pretty epic.
Does anybody not know what option is? Because I just did it. I really ask anyone to know what option is.
What?
Does anybody listening know what option is?
It's a endofunctor. Wait, no. Damn it. It's a monoid in the category of endofunctors.
Right.
You literally pulled that line on me
Yeah.
when we were learning monads.
Yeah. Well, he's not wrong. Okay, so the option is essentially. How do I say this? Imagine if I have. Imagine if I go to the shops, right?
Here we go. We're going to the shops again.
If I go to the shops, right, you expect me to come back with some groceries or nothing, right? You don't expect me to come back with a car or like, a guitar. You expect me to come back with some groceries or nothing, right? So,
Please milk.
please milk. If we're making a function, right, that Shrey goes to shops, how do we type it, right, such that the return value is either, some groceries or nothing, right? It should be impossible for someone to write a function, Shrey goes to shops, that returns a guitar or a car or something, right? The only possible return time should be some groceries or nothing, right? So how do we do a return type like this? And the answer lies in in none, where in option. Please give me something nice. No. This is not giving me something nice.
Yeah, so option is the type-safe version of null. Like
Yeah, options.
yeah, literally. Yeah, it's null but in a type system.
Yeah, pretty much. So I can say option of something. Oh my gosh, I can't type. Oh my god. Oh my. Option of string.
No, option none of that. There you go.
String. So it's either going to have the groceries that I got as a string, or it's going to have nothing, right? And so the way we return stuff then is like, this print number function takes in an option of an integer, right? So sum 13. I can also, print number of none, right? This is a pretty bad example for when you want to use option. Like you would never. There's not many times that you want to pass in an option. Well, that's really a lie, but like this example doesn't really highlight it. But that's what option is. It's like a type-safe version of null. But the function never returns anything. If the function never returns anything, then you wouldn't be using a return type. You're using something like this.
Well, no.
Right?
If the function doesn't that's not right. If the function doesn't return anything, it won't compile. If you tell it to return an option and then you don't return anything, it won't compile.
Yeah.
Yeah. Oh, I see. I thought it was a joke, but I was like, I'll take it at face value.
What if I don't come back? Yeah, true.
Yeah. So, and this very closely ties into exactly what you were saying earlier, Ollie, about generic types being a parameter on like a type, right? You have option of t, where an option can be an option of any other value. So that t could be an integer, it could be a string, it could be another option of something else, it could be, that t, it can be crazy types. You could have a tuple of 3 options and the third option is an option of an option of an option of an option of some other type, but it can be an option of anything. And literally what that type means, if I say I have an option of some t, I will either have a t to give you and say, yep, I have some t, here it is, it's yours, or I say, sorry, there's nothing, there's none. Tea time, yeah. So it's literally just a way of expressing, like, the problem with null is that you don't know where a null may or may not appear. Whereas with an option, you're literally saying, you're allowed to say null here. I'm expecting you to be able to say null here, and for me to use that value, I have to explicitly check that what's there is not actually null.
Yeah, and that's why in my function as well, I can't give it 13, right? And 13 is a number, right? So why doesn't this work? Because 13 is not an option. 13 is an integer, right? So to pass in the type-safe thing, you should like wrap it in an option. And say something, right?
Yeah, more specifically, there's that maybe number dot unwrap on line 8. And what that unwrap there is saying is, give me the U16 inside that option of U16. So give me the U16 inside. If it's none, if there's no option to give me, panic. Like, literally, like throw an exception, crash the whole program, and say, there was a panic on line 8, something messed up. You shouldn't really unwrap, because it goes against the whole idea of options. Like, that's basically like getting a null pointer exception and having a big freak out anyway. So usually you'll do something else instead. You'll say, maybe you'll return an error result, or you'll just not do it if it's none, or, stuff like that.
This turn is really bad example, because you can't even pass in a none, it just panics.
So it's forcing you to null check is why I'd say, yeah.
Because like we want to null check sometimes, right? There are cases where you want something or nothing, right?
Not only that, but the existence of option in a language. That's not true, actually. What I was about to say is, languages that have option have this nice feature. Not true. Like Java has option, but it also has null. So you can have an option of t is either sum of t, none, or null. Jesus Christ. But like in a language like Rust, the sort of other side of the coin, which is where this becomes really powerful, is that since we have option, we don't need null. Since we don't need null, we don't have null. Since we don't have null, any value that we ask for, like if I ask for a string or a foo or a bar, if it's not an option of that, I know it must be there. I know it must exist. Right?
Alright.
Like, I don't ever have to null check anything that I don't explicitly say option of that. Really handy.
Oscar, Java bad is my solution to your problem. Kidding. Java has its strengths.
Java's option is actually very bad. Atlassian has a nice article about it. Some dude on behalf of Atlassian.
Cool. Next one. Last one. I said that 40 minutes ago. Okay. Makes an if let statement which values some type. So, if let some string some string.
Equals what?
Yeah, that's no optional word.
And it knows that there's a string inside that option, right? You never have to say, like Rust will always, infer the types. What goes there?
Oh, that's the word.
Word, right? It's like, if it's some of this inner word, and then that inner word will have the type string as opposed to the type option of string. Yeah. And then you have to do it down there or something. I don't know. Oh yeah, no. Oh yeah, while let super fucking cool. Sorry, excuse my language.
I think while let
because pops the top thing off the vector, which may not be there, so it returns an option of t. Yeah.
Huh.
While I pop and get something, optional. Oh, because it's look at what they've got. It's a vec of options. Don't just unwrap. Don't unwrap. You can actually make your while let even crazier.
Can I match out an integer?
Well,
Why doesn't this do it properly?
because
It
it's pop. No. Because pop returns a option of t, right?
Yeah.
And look on line 17. It's a vec of option of i8. So what pop returns you is an option of i8.
Oh, pop returns an option. Oh.
Yeah, because there might not be anything left in the vec.
Right.
Yeah, exactly. Very epic.
Option of option. We love it.
This is actually I really wanted you to do this because it's very cool to look at, but it's actually bad because that will keep looping while we get some integer, right? Except you could imagine that there's a none value in the vec halfway through.
Yeah. Right.
And then it would stop. So but it's very cool to look at. So actually what you would probably do, you should probably do while let some option.
And then a while let in here.
Not a while let.
Oh, if let. Sorry.
Yeah, exactly. That's much better.
Equals to option.
Yeah. There you go. That's a very good impl. Nice. You should do optional integers vec of 5 equals none.
Oh my gosh, where all the autocomplete's broken.
No, just do of 5, array syntax of 5. Or of 4 or whatever. No, array syntax. Array index syntax.
How you do it?
Array index syntax.
Oh,
I can see.
It's changing its mind.
No, it doesn't. That was a tuple before.
Why is it different syntax?
No, the actual great thing is that index, the indexing operator is a trait, so you can implement indexing on whatever you want.
Okay.
Your own types and stuff, which is very epic.
Yes, X monad is good. We should do a whole, sack Rustlings. We should do X monad strings.
Someone should do a talk about Xmonad honestly, like a workshop.
No. I actually wasn't on Xmonit though, we just happened to have Xmonit in it.
Alright.
That's a good idea.
ZSH theme. Oh, you gotta make ZSH theme.
Nice. Very
Okay,
good.
what are my ZSH themes? Let's have a look. This one, which is very brightly coloured because I like to be awake. I have.
I actually like your theme.
Thank you. I have this one on CC, which is a bit darker.
That's more like my theme, but mine's
And I
darker
have
than
this one for my class account, which is a bit of both. This is
That's
Tom's
probably the closest to mine. Yeah, that's quite similar to mine.
one. This is Tom's one,
Oh.
which I stole. What was those?
What is the numbers on the top right of my theme? Oh, this?
Background jobs?
Yeah, that's my local IP address.
Got him. DDoSing him right now.
Local IP address.
Yeah. Local. Good one, bucko.
10, 10, 10.
Damn, how'd you get 3 10s?
Yeah, so lucky.
Hey, what's your public ID?
Yeah, let's hack me. No, I'm not gonna do this. This is on YouTube. Because that's just what I got. Shrey, you just did networks. What's that thing called again?
DHCP.
DHCP. There you go. That's just what I got. DHCP. The router went, this one's free, and gave me that IP address.
Good on the router.
Yes.
Alright. I'm gonna go off. We've done. What have we done tonight? We've done collections. We've done enums, error handling, functions, generics, ifs, Mac modules, move semantics, option, prototypes, strings, structs, variables, quiz 1 and quiz 2.
So wait, what do we still have to go?
Where'd my terminal go? Oh no.
Clippy, conversions, macros, standard library types, test threads, traits. Cool. 10.10.10 is a very common subnet. It's there's certain IPs get weird. I think potentially 0 through 9 have certain semantics about them, and 10 is just the most convenient small number that doesn't like have any weird specific semantics about it. Actually, yeah, because you need it to be recognized as a local IP address as opposed to a external one. For example, Google's 8.8.8.8 DNS or Cloudflare's 1.1.1.1. Oh yeah, you guys are there you go. So, but 10 will be 10 will be recognized as a local address.
Traits, threads, tests. Can we just do tests on them?
Dude, doc tests. I saw some people learning about doc tests on Twitter today, and they were like, "Holy shit, this is the best thing I've ever seen." Do they? They don't teach doc tests. God damn it.
Alright. You gotta end the YouTube stream.
Wow. What are we at? 3 hours 20 minutes.
Too long.
Okay. Bye YouTube stream. Say bye Shrey.
Bye,
Say
Shrey.
bye Oscar. who's left here? Or not. Oscar doesn't have to say bye.
Love you too.
Oh.
I'm leaving now.
Huh?
Wow.
Alright.
Actually watching.
Huh? Yeah.
Yeah, Liv was watching.
Bye.
Although I think she left a while ago.
End stream. Okay, stream is ended.